The Earth is very flat.
What's going on, everybody? It is Brandon for Brandon's Show. Happy to be here. Once again, screwed over by the fine people at Comcast Xfinity, who seem to have the same maintenance window as the show. But anyhow, it is Friday, February 5th. Happy Friday, everybody. Glad we got the show up and off the road. The world seems to be conspiring against us this week, but that's okay. Let's see, what do we got going on today? We've got to look at Wally's satellite response. Take a look at that with the guys in Discord. Pebble in the Pond is in, so maybe he's going to go through his idea, because I'm pretty sure I butchered it pretty badly the other night. So we'll see what he's got to say. And then there is, I think White's World is the username. White's Word. White's Word has contacted me via email and has an idea and some access to some land, evidently. So I'm really looking forward to her hearing that. I think she said that she was going to join the show at some point. So we'll see what happens there, or if I misunderstood her intentions. Either way, it's all good. Let's see who we got in chat. We got Mark Collard, YouTube, Dan Morris, Bill G, a natural law abider, Cleary, Jack653, almost unbelievable. What's up, Randy? Page 42. Got a bunch of people. Bob Nodell's Gyroscope, Ian Adams, White's Word, Rob Keane, and Chrissy Heavey, Gadget Inspector, Grave Dodger. I'm going way back now. I think that's about it. If I missed you, I apologize. If you do want to support the show, here's a link to Streamlabs, and I'll pin that at the top. Just so everybody knows, if something happens and for some reason the show's going to be late or delayed, I will put a message at the top of the live chat and reschedule the stream. So if you see the stream is rescheduled for a time there's not the normal time, that probably means something's going on. I have some kind of commitment or emergency that came up and won't be able to do the show, and I will put a message on the top of the live chat. Hopefully that's visible for you guys. I think it is when I pin that up there. Hopefully everybody saw that yesterday and today. So I think that's probably the best way to let people know, besides sending out a notification to all 5,000 viewers. I don't know. Let me know what you think what you would rather have me do. Notify you through the YouTube, what is it called? Notification thing, or just pin the comment. I don't want to flood people's inboxes or their timeline with notifications saying stream's delayed. But anyway, I think you guys can hear me. Microphone looks good. Stream looks good so far. Cross your fingers. Hope everything goes all right. And let's get into Discord and say hello to everybody.
So there's going to be a lot of people. I'm not saying everyone's going to do this, but there's going to be a lot of people.
I'm paying my rent. I wouldn't stop just because it was an opportunity maybe to pocket some and never have to pay. It's a scam, you know.
What's up, guys? We're live.
Hello, all you biatches out there. That wasn't me said that.
Who was that?
Yo, what up?
Let's see who we got in here. F.E. Fairy Tale Extraordinaire. Welcome to the show. I don't think I've seen that username in the show before. Is this your first time?
Me, Ed.
Huh?
It's me, Ed.
Oh, hey, what's up, Ed? You got a new name, huh?
Yeah.
Okay, cool, man. What's up? Jeremy.
Yo, what up?
What up? Jimbo.
Putain de bordel.
Potato in the pond.
Tired.
Did I just say potato in the pond? Why did I say that? Sorry about Pebble in the pond. Sorry about that. I don't know what the hell's wrong with me. I think I read the word potato on my overlay here and it stuck in my head. Tired. Yes, you are up late. And I want to give you an opportunity before we do anything else to go through your idea if you want to. Your choice.
Yep.
Cool. Let me say hello to the rest of the people and then we'll come back. We'll start that right away. And we've got SE Montreal. What's up, SE? You might be having audio issues. Your mic is staying green, so you might need to drop out.
Yo, If you leave gems and come here, you got to just leave and come back right away because something's weird.
Yeah, you get like
Okay, I'll do that.
Discord cooties from.
Oh, we hear you.
gems.
Yep.
We hear you.
I'm good.
Yeah, you're good.
Yeah, you're all right now.
Cool.
What up?
In Discord, you're gonna see an account with a weird thing on it. I don't know what those are called. That's me. That's my other account. I finally spent the time to figure out how to share from my phone so that I can play a YouTube video and you guys can hear the audio in Discord. So that's who that is with that tool looking album cover thing called sharing account. And then
How are you supposed to be a high ranked? Oh, my bad. Go ahead.
Bob Dole. What's up, Bob?
Hello.
Hello. Were you gonna talk some shit, Jeremy, or what?
How you gonna be a high ranked? How you gonna be a high ranked flat earther and not know how Discord works, bro? Come on.
I'm just an amateur, dude. I'm just.
No, you're up there. You're high ranked.
I don't know about that. I want my. Well, where's my fucking paycheck if I'm high ranked, huh?
Yeah.
Anyway, so yeah, let's go to Pebble. He's got an idea. I butchered it pretty badly the other night, so let's give him a chance to clear it up. I did read the email that you sent, Pebble, and it made a lot of sense. I'll save my comments for after you present. So whenever you're ready.
Was this the X's? The X's?
Yeah, this is the one with the X's, which is what I focused on when I presented it.
Yep.
Okay, you're sharing. Let me click watch stream here and share it with everybody. There we go.
Yeah, so I kind of confused you when I had that X idea. It wasn't what I was meant to explain. It was just an idea to try and make a straight line, but
No, it was me, bro. It
Yeah,
wasn't you. I'm an idiot.
all right.
It was me.
All right. So what we got here is the idea of making those molds out of cement or whatever it was. Yeah, so the brown line is the trench that we would dig. The gray line here is the mold that we'd make, concrete, whatever material it would have been, and then the water on top. And that was like was that Jeremy's idea or whose idea was that?
It was mine, but I have to give some credit to Brandon, kinda. Not really.
Yeah, so that was like the first idea that we had, and I wanted to like show it here, or my understanding of what I thought you guys meant with that test. So there's like a view from above of those molds. They appear or look straight, and if you would like rotate them towards each other, the gaps would be the same on each end there. But on a curved surface, you would get something looking like this.
That's if it's
Depends
one
on-
solid piece. If it's one
Yeah.
solid piece. Yeah.
Now, it just depends on which way you rotate them, but you either get this shape or then this kind of shape here.
Yep, you got it. It's that simple. Exactly.
So, and both sides agreed that if we could do this, it would work. But the hard part about it is just actually getting this done, and the difficulty of actually physically rotating these molds here.
Yeah, when you think about it in your brain, you're like, yeah, we can take a trench and pour some concrete in there and then flip it over. But what my problem was, I had to think about how actually long even a mile was, or 2 miles. You're talking about like 10 city blocks for a mile, flipping something on its
Yeah.
side. And in a mile, we would want to do more. So yeah, the logistics are just insane.
And then after that, you guys thought about having just the 3 posts, but we ran into problems there, so that idea was like gone.
Yeah, as
But-
WS said, it was a nice idea for a very complicated way to turn 3 posts on its side.
So what I'm thinking here is zoom out a little bit. I'll just keep it zoomed in. Yeah, so what I was thinking here is we still dig that trench. We fill it with water, or then we just find a calm water source. So there's like no waves, no wind, no currents. As long as the water is calm, so that'd be good. Then we still use posts. We hammer them into the ground. That way they're stable and they don't really move much. And
all plumb. We're gonna make all the posts plumb.
Yeah.
Okay.
Now, when we hammer the post into the ground, we make sure that the top of the posts are all the same height from the surface of the water.
Okay.
Right here, I've just drawn 4 posts. I don't know how many we'll use, how many we'll need, but there's just 4 here as an example. Now, once we have all those posts hammered in, we have also 2 lines of these. Just like we have on this test here, where we had the 2 molds. We have 2 lines. Now, somehow we're going to create the straight line. I don't know what method we're going to use. Whichever one will work, and whichever way we can agree that it is actually straight without having any sags or other turns or twists or whatever.
Now, by straight, you mean perfectly straight as in the Euclidean straight, not the ball curved straight, right?
Yeah. Yeah. Yeah, I don't know if it's going to be physical or just measured, or this red line is just like showing like it's a straight line. But on the posts, we mark the position of where that straight line is. So on a flat surface here, we'd have the line starting at the top of the pole. So let's say if the pole is 1 meter from the water surface, then that mark would be at 1 meter. And
if we can make this, hold on a second. If we can make the straight line, we don't even really need to do anything else. You know what I'm saying? That's like the whole problem, is making that straight line.
That's the whole point of it, is trying to come up with a free line in space. And for anybody who's listening, the tough thing here is not showing that, I mean, the point is it's hard to show that it wouldn't work on a curved Earth with the bottom curving with the top. It is unbelievably, insanely difficult to come up with a test.
Let's hear Pebbles out though.
Miracle trick.
Hold on, let's hear
after him.
Okay, I got one after you. All right, go ahead. Go ahead, Pebbles. My bad.
Yeah, so every post has now that mark on it. That it's 1 meter from the level of the water. Now, since these posts are hammered into the ground, they won't move. And if each post is 1 meter tall, then we make the gap between the posts 2 meters, so that if they would be rotated towards each other, they would meet in the middle. So here on the right side, we have a view from above, and if the post would be rotated, then those posts would meet in the middle, and the marks that we had on the posts would also meet in the middle here.
How much curvature would you expect to measure over 6 meters?
No, these are just estimates of the.
Right,
I'm
but you said like 2 meters between them, so that's 6 meters total, I guess. Or are you gonna dig the trench longer?
I don't know how long we're gonna dig the trench, like whatever distance we need. I'm just giving some numbers right now to get the idea. So that was like a flat surface, and then here on a curved surface, we have the same straight line going across, and as you can see on the curved surface, that straight line will, on the middle post, will be lower than that 1 meter mark. And if we look at the same lines from above, they appear straight, even though there would be a curve here. But since we're looking at them from above, they look straight. But now if we would rotate the posts so that they're facing each other, the marks on the posts won't meet in the middle anymore. So in a way, we've captured that curvature without needing to physically turn anything. So
This is
pretty
dependent
much-
on us making.
We've
This is
pretty much done
dependent.
this without needing to physically turn anything.
This is dependent on us being able to make that straight line, all right?
Yeah.
Yeah.
That's the problem, Pebble. That's the difficulty that we're running into. Is how do we
Straight
make
line,
a
yeah.
frickin' straight line?
Yeah, because if
'Cause
the,
if we
bottom
can-
line's curving with the top line, then it always works out mathematically. It's fucking insane, dude. And there's a
If we-
few things you can do, but it's very rigorous.
Yeah. Go ahead, Leaky. Were you done, Pebbles, or?
Well, that was pretty much it. I was just wanting to show
I
that,
love the way you're thinking, man. And
we
shit,
yeah,
I
could
don't
capture the
recommend
curvature
anybody
without
stop
needing
thinking.
to physically turn anything.
Yeah.
It would
The
work, but
distance
it wouldn't
is how
prove
far
it.
we
It wouldn't
go and the
suffice
heights
to
of the
them, bro.
post, those can change, but this, like, of course, this can
All
be
these
improved
ideas
upon.
we're coming up with. All these ideas we're coming up with works for me, but it just doesn't work for them. They'll say, look, on a sphere it would do this, it'd do that. You know, so what we're so
Well,
that
I
we're
do have
taking.
one question. How much curvature do you expect?
7.
Well, it
Any
depends
at all, Ed. Any at all,
Seven.
how
buddy.
far of a distance
7.
you go.
No, right. So if you're, let's say you're gonna be honest about this and assume it, not gonna assume flatness or curved, because that's what you're trying to find out.
We're not assuming anything,
So-
you're right.
Right, exactly. That's good.
Yeah,
So,
yeah.
how much over any distance, how much curvature would you expect if it was curved, if it turns out to be curved?
3.
Yeah, that's not an answer. Jerry.
However long the line is, you know, we'd use the curvature formula, and the middle should be the difference between the middle and the two ends should be the amount of drop over that distance divided by 4.
Right, so you think it will be noticeable, the curvature?
Oh, it definitely will be a difference if we can make the lines, if the line's straight and we can get good measurements down to the water, there definitely will be a difference between the two models. This right here, what he's got, absolutely, if we could execute it, would falsify one or the other model.
Right, and
I agree.
what distance are you going for?
Well, I wanted to go, you know, because this is very similar to an idea I pitched a while back. I'll have to show that to you, Pebbles. You may have never saw it, but I came up with some ideas for how to make the straight line. We've kind of abandoned them, but I'll send it to you anyway. And what was the question?
I think
again?
we need to
Shit,
go.
forgot
I
the
think we need to
question.
go 2 miles.
Oh,
I think
how
we need to
long?
go 2 miles at least.
I
That gives
wanted
you
to go
an 8-inch sagittal.
I wanted to go 6 miles, but that's obviously
The,
retarded. So
the longer
probably
the
like
better.
3 miles, 4 miles. Yeah, the longer you go, the more
yeah.
you don't have to worry about
gotta go
error
2.
modes.
Well,
You
let's
go
say
2
it's
miles
two.
at
I got a
least.
2 mile
Let's go
idea.
with let's go with 2 miles from Jeremy. Well, then how are you gonna get something that is that doesn't flex enough? It's not flexible enough, so it will be straight over 2 miles.
Yeah,
That's
exactly.
kind
what
of
we've been
material?
brainstorming about for the past year. Welcome to the party.
Right.
Literally, we have not thought of a viable way to do that yet.
I got
Yeah.
one that might be viable, man. If y'all
I got
if we
another
put our
one
heads
after
together and
Leaky.
expand on it.
I
I
got
got
another
one
one
that
after
would
Leaky,
probably
go
work over about a mile and a half. So if we say the beginning of the mile and a half, I mean before you knock it, think about it for a minute.
Oh, hold on,
Okay,
Brian.
so
Hold
we
on
started up-
one second, Brian. Pebbles, thank you for the presentation. This is good stuff. If you can think of a way to make that straight line, that's the difficulty. That is the major
we-
problem.
Keep it
Yeah.
up.
I
Good
definitely ain't
work.
done. I
Hardest
definitely
part
ain't
about
done talking about his idea right there. I'm definitely not done with that. I just wanted to run something else across, while we're talking about it. But yeah.
Okay. I just wanted to
More-
make sure
any
he
idea
wasn't
is a
lost
good
in the
idea,
shuffle
right?
because I know he might have to go. But go ahead, Brian.
So if we start at a point on top of the water, okay, at a calm body of water, and I recommend we do this in the water for support, and we get, it might cost a good bit, but it's not a crazy amount. So we start one spot in the water, we go for about 1.5 miles, and let's say if the water's curving down, then something rigid floating on the water is curving away from us. After, let's just say 2 miles, okay? So after 2 miles, it should be dropping down, 32 inches? So that's why I'm saying we could probably go 1.5 miles, which is probably more about 2 feet or so. And after 1.5 miles, let's say we take some, 6-inch PVC and float it on the water with an end cap and glue pieces on as it's floating on the water and glue them together, sturdy. Where it floats and cap each end off, where we basically have like 1.5 mile stretch of 6-inch PVCs, 20-footers, and so it's going to be a little bit flimsy as far as up and down, but supported on the water.
Brian, that's going to be too heavy. It's going to be curved towards the middle.
But it's not going to be heavy at all because it's going to be floating. Okay, it's going to be floating. Okay, so we float it on the water, and then we roll it. We roll them all. We need a bunch of people rolling it, or a method to roll them equally, but it's not like they're going to roll out of their...
Brian,
hold on, let me finish.
But
there's
some
let me
problem
finish,
with
please.
this.
Ed,
This
let
is
him
not
finish.
gonna
Let him
work.
finish, and then you can have the first crack at him. Go ahead.
Okay, so if we roll them all equally, okay, and we make a mark on the side, and then roll it over. Okay, so we got to roll it over 180 degrees, and if we roll it all equally, as long as it doesn't come unglued, it might bend downward. Okay, it might still bend downward weight-wise, but the way we glued it together, the ends should be about 4 foot apart at one end. If we roll them out away from each other, like picture a bend to the right, and if none of the glue comes undone, it might bend down with the curve, but it would still necessarily have to bend out away from each other at both ends. So consider that one.
Could I
Never
try
supporting
something
it in
here?
the air. It's always on the water.
Hold on.
All right, so if the thing is always underwater, then how can you determine if it's flat or curved, if it's gonna have the level of the water, and you
I
don't
can
assume
add
it's
to
either
that.
flat
That's
or
the whole
curved?
point, bud.
I know how to
No,
do
but
that.
then, Brian, don't you understand? If the thing you're using to get a line is gonna have the level of the water, and you don't know if it's flat or curved, then that is not helping in your experiment.
Can I propose something here?
Yeah, but
Yeah.
all right,
Now,
go ahead.
can I say something? Okay, now I like the idea of something stable floating on the water. Now, if you have a pole running up, like little pole, I don't know how many feet, but a light that goes off at a 90-degree angle towards the other horizon, and if you're a mile away from it and it's leaning away from you, that light will be pointed upwards. In fact, if there were a few lights on poles pointed horizontally, level with the water, and you go away from them, interspaced, then they all should be incrementally going up if there's a curve.
Well, our best bet that way is to put something real high in the middle. Like, say we set a mark at like 8 or 10 miles. Say there's like a 30-mile hump, or I mean a 30-mile hump, like a 25-foot hump, is just to put a big light in the middle. That's where the lights you sell would do good over that distance.
Yeah, Brian, that's not gonna work.
But it still might line up due to optics, though. That's still optics.
So that's not gonna work. The material is flexible, and if the water is curved or flat, it's gonna take the level of the water either way. So you can't use.
So is it gonna uncurve then? I mean,
Brian, so you can't use that to determine if it's straight or curved. You can't do that. You need something that's not so flexible.
All right, let me pitch my idea.
Unbend, though?
When you're done, Leaky, let me know.
Yeah, I was just going to say, if we got these stretches of pipe, and we have them. They're basically touching each other. They're touching each other, and they're bending down at the water curve. And then we just and then we roll them out away from each other. Are they going to unbend, or are they going to be farther apart at the end?
They're still going to bend.
That's it. Yeah, we expect them to bend down gravity, right?
Yeah,
whatever you want to call it.
That's not the point. They're still going to take the shape of the water, either flat or curved. It doesn't matter. So you can't use that to determine if it's flat or not. You need something that's not so flexible, Brian. Skip the PVC pipes. That's not doable.
All right, here's my idea. Are you done, Brian?
Yeah.
I'll go after you, Jeremy.
I could wait. Go ahead.
No, you go. You're in line.
All right, here's what I got. We're back to the fishing line, right? We get neutral buoyant fishing line. You clip you clip 3 or 4 pieces off it. You get a sample of the water that you're going to put it into in a bucket or a fish tank or something. You take these little pieces. You put it in the water. You check it every 5 minutes. You mark the levels of where they're at. You know, you put one at the bottom, one in the middle, one on the top. You check it every so many minutes. You see if the line's going up or down or if it's just staying right there. So we figure out we're going to want the line to sink because that helps the globe so they can't cry afterwards. So if the line goes up, you can't use that line, right? But if it goes down very slowly, you got some very close to neutral buoyant line. So essentially this line is going to go wherever you want it to in the water. So you do the trench, the 2-mile line. You pull it tight with the winch. You got the scale on it so you don't break the line. You know how much test. It's essentially like making a plumb line horizontally. Any problems? Questions, concerns?
Yeah, a problem,
No,
huge problem.
That's pretty, that's a great idea,
the line is also flexible material, so it's going to take shape of the gravity. So I'm not saying no.
Hold on, were you listening?
But you don't understand. I'm not saying.
Were you listening?
Yes, and I'm not saying the Earth is curved or there is gravity, but that's what you're testing for. So if it's gonna have the effect of gravity on the line on a piece of string or whatever, it's not gonna be straight.
Ed,
Gravity.
you're totally missing the point, bro.
If the line goes down, listen, you guys need it. The globe needs an expected amount of drop in the middle, more than the ends. You know, you got it a foot deep on each end. You're going to need over 2 miles. You're going to need a foot 8 inches in the middle. If the line slowly starts to sink, when we check the buoyancy of the line versus sample water we're going to put it into, that helps you guys. So we ain't worried about that.
No, it doesn't, because it needs to be straight.
That's pretty much my idea. But don't let Ed cut me off this time, Brandon. Mute him if you got to. But listen, y'all, if we have them PVC pipes sitting on the water, okay, and we have them marked, okay, and we have them button up against each other, just a mile and a half and a mile and a half of PVC pipe, and we glue them together, okay, and cap them off where they're floating, okay. If they're all marked, okay, on one side of the water, when we glue them together, when we twist them away from each other, if every one of them pipes, if each and every one of them pipes goes from one side to the other, and it's true to its mark, then it has to be. I understand it might still be bending downward with the water. Gravity might hold it on the water, but it's still going to have that bend. If every pipe twists same amount from one side of the water twisting out away from each other, then the distance between the end necessarily has to be more distant. But where we glued it together, if we rotate them all the exact same amount, it's got to show it if it was bending in the first place. Or it could twist, but the marks wouldn't line up. You see what I'm saying? In other words, it could twist and the test could fail. But if all them marks went from one side exactly to the other, there must be separation at the end if it was bending to begin with.
Right, so flexible materials won't work. You need something that stays straight.
My idea will stay straight because the line's neutral buoyant and it goes anywhere you put it in the water.
How are you going to keep it straight if it follows the level of the water?
It doesn't follow the level of the water. It's neutral,
yes, it does.
Neutrally buoyant.
Yes, and it's neutrally buoyant at the same point in the water everywhere. So it's gonna follow that shape of the water, curved or flat.
I don't think you
So
understand
your
what
test fails.
I don't think you understand what neutrally buoyant means.
I just explained how it doesn't work because it's gonna
How about
follow.
this?
You think that there's
You
going to be
can't- you
that?
can't-
You think that's
He
going to
don't
be that
understand. Let me
sensitive
explain it
in that water where the neutral buoyant will naturally stay at that exact density within that water that it would curve
Right.
if
Brandon's all over it.
come on,
Brandon's all over
man.
it.
Oh
That's
my
the
God.
whole. That's the whole point. It's gonna stay at that level and follow the
Dude,
shape
that's
of the
ridiculous.
How come?
That's
water. Flat
ridiculous,
or
bro.
curved. No, actually it isn't.
It is.
How can you not understand that?
I do.
Because you're not assuming. No, hold on. You're not assuming it's
Dude,
flat
you're
or
a fucking
curved.
retard, dude. You're not
no,
not understanding.
no, Brian,
or you're a retard.
Brian.
The
Benefit
little
the
bit of
doubt.
pressure we're going to put
And
on
try to
that line
explain
to
it
try to
different.
pull it tight is going to overcome that whatever that force is you're talking about that's going to keep it at that
How are you
exact
gonna
density
have
profile.
it exactly straight? How are you gonna have the piece of string in a straight line?
Ed, what if it floats, buddy? What if the line floats and we
Yeah,
can't sink
it's
it at all?
approximately
We put it tight, we do whatever we can, but we
neutral
just
buoyant.
can't sink it.
Right.
We
Yeah,
just
we're gonna
can't
get it
sink
so-
right?
Hold on. We're gonna get it neutral buoyant, but like I said, we're gonna check take a water sample we're gonna use, and we're gonna clip a few pieces off the line and set them in our tank, so that over
Yeah, but
time.
as soon as you go
Hold
any
on a
deeper, you're
second.
gonna have a different density.
Sorry.
Brandon's got it. Brandon's got it.
No,
Okay,
it's a ridiculous thing to say that that's going to happen though, Ruif.
The
Yeah,
line
we're gonna
item
set
is
them in the
gonna
water.
float
We're
in
gonna
the
set
tank,
these.
bro.
You're just
Jesus
saying
Christ.
it's ridiculous. You're not explaining why.
Oh, yeah, I did. I
I'm gonna
already
explain
explained
why to you right now.
No, and I debunked it, so
No, you didn't.
now it's your turn again.
Hold on. Just hold on a second, guys. Let's not get fucking crazy. We're gonna snip a couple pieces of our line off, get a test sample of the water we're using. We can do this multiple
Yeah,
times.
you
We
said
can
that
do-
5 times, and it's gonna
Okay,
stay
we can do-
neutrally buoyant at the same level in the water, the same depth
No, it won't.
Correct.
everywhere. So
We're gonna put the
and
line
it's
in the
gonna
water.
follow.
If you
that
can
means,
shut up for a minute, I
that
would
means it's
explain
gonna
it, but
follow
I
the
guess you
shape
can't.
of the water.
Ed, don't
Curved or flat.
blow the hangout up. Don't blow the hangout up.
Yeah, that's not what I'm doing.
Seriously, we're all calm, relaxed. Now we're gonna put the pieces of line in the tank. We're gonna see how they react to the water. I'm guessing we're not gonna be able to get them perfectly neutrally buoyant. However, we will be able to get it close. So if we come back 4 hours later and all the lines went up 1 inch, we're not using that line, because if it goes up, that hurts the globe and it won't be definitive at that point. If we come back 4 hours later and the line's 1 inch lower, we're using that line. Because if the line sinks, it helps the globe.
That's what
And we don't
happens
want
when you
nobody
put a filament.
Yeah, that's what you've said, but you didn't explain how it helps the globe, and it shouldn't be
It
helping
helps
the globe.
globe.
It should be helping-
I'm gonna
hold on,
explain how it
hold
helps
on,
the
hold
globe.
on, Jeremy.
Jeremy's right.
It should
I'm
be,
gonna
hel-
Ed,
explain.
Jeremy's right.
but it should be
Jeremy.
helping your experiment. It shouldn't
Thank
have
you,
any
Rumpus.
bias.
Tell
It's
him what's up,
ridiculous.
Rumpus. Tell him
Be
what
quiet
time
for a
it
minute,
is.
Ed. Jeremy,
Tell 'em what time
monofilament
it
line
is.
does slowly sink. Just
That's
so you know.
fine.
That's what
That's
what I
fine.
was gonna use.
As long as it,
Monofilament line, it's neutrally buoyant, but it does sink a tiny bit, man.
that's fine. We
pull
get
it
it
down.
close. Yeah, that's fine. Thinking helps the globe because they need more depth in the middle. I don't want nobody crying like a little bitch after this, right? So if it sinks, they need more depth in the middle. If it sinks, that works for them. They can't bitch about it.
Right. If we pull that line tight, if we sink it down, okay, this is my idea with that. I use the line that's pretty much neutrally buoyant. It kind of goes down a little bit, but it's pretty much neutral buoyant. We sink it all. I mean, we sink it over 3 miles. We sink it 2 foot in the middle and transition it outward where it's fairly tight, and we pull it super tight. Okay, and if it nudges upward, then if it nudges down, then that means it's a globe, man. If the
thing
middle
with
of the
this-
line
Jeremy,
nudges upwards, it's flat.
if it does droop, if it does sag because it's slightly not neutrally buoyant, you're going to dismiss this test and say, well, actually, we used a line that was not quite neutrally buoyant, and so you're not going to accept the result if it shows it's a globe, are you?
Would you
Hello,
accept it if it showed that?
Yeah.
Would you accept it?
Yeah, I'm in the fortunate
Hold on a
position
second.
here.
Hold on, I didn't get a chance to respond.
Well, I agree with you. Okay, so I know what you're going to say. Apologies for interrupting, but I know what you're going to say. Yes, because as you say, doing what you're suggesting would favour the globe. So if you were to get
Okay.
a result where it was stayed above, then yes, I would. But
Okay,
the
good.
trouble is, there are two reasons why it's not going to work. One is the sag, which is also going to favour the globe, and
There's
two,
no
the
sag.
fact that it's
What sag?
not neutrally buoyant.
What sag?
Well, sorry. When I was going to say sag, if you count it neutrally buoyant, then it would. I was imagining if I'm going to take that back because I was focusing on what Brian was talking. Yes, I'll take that one back. Sorry, I was focusing on what Brian was thinking about pulling it tight. It will snap.
Let me explain. Okay, we're gonna have a scale on it to make sure that we don't pull it more than the tensile strength of the line. Obviously, we're not
You
gonna
have
let the fucking
to
line
make it
snap.
straight.
You need a scale to make it straight.
You will not be able to put it. You will put too much to make it straight. You will have to put more tension on it than it can take.
The line goes. Do you know why a plumb line stays straight?
There's not much force in it. Yeah, but there's not much force in a plumb line.
Because you put a little weight at the bottom, and you make it go straight.
Yeah,
but
the
line
force
will go anywhere
you're going to have to apply over 2 miles or whatever will be enormous to make it be straight. It'll be affected by little currents in the water. It'll be affected by convection. It'll be affected by the wind.
Slow down.
To make that straight, you will have to put more tension on it than it can take.
Correct.
No, not necessarily.
Slow down. We're going to have a controlled body of water. Okay.
Yeah, but it's in the sun, which means it'll have convection in it.
Okay, there's going to be no turtle. Okay, so we need to make a shade to shade it off. You want a shade for this
That would
thing?
help, but it'll still have some temperature difference, which mean you'll have some very slight flow, and you only need the tiniest amount of movement of water, even if it's just circulating, and it means you have to pull it tight beyond its tensile strength.
So if a bird poops in the water, it's invalid?
No, just one bird pooping is not going to be the problem. It's going to be some net effect, like some heating, convection, wind. Any movement of that water over a distance of a mile or two will put so much force on it if you try to keep it straight.
Do you think the water's going to move a lot in a trench that we dig, though?
Not a lot. No. It won't move a lot, but it only has to move, say, by an inch, and you try and get that last inch out of it. The tension you'll have to put in remove that last inch of deviation.
You're worried about the wave on the top, the waves on the top of the water? What are you worried about?
Well, any movement of the water. If the water was perfectly still, then I would agree with you. But I don't believe there's any such thing.
Well, so this can only work in perfectly still water. If there's a fucking bird poops in it, then it don't work.
One bird poop wouldn't be a problem.
How many birds can poop in the water?
10.
2?
Well,
10.
We can go somewhere where there's not a lot of birds.
10 bird poops? All right.
Yes.
Okay, 10 bird poops. Okay, this is going to be the stillest water we can get. Unless someone has an indoor thing, this is going to be the stillest water we can get. I mean, you're never going to get...
Sorry to interrupt you, but you could try this out. I mean, if you could, before you start going to some amazing expense, you could try and find, I don't know, a pool or canal or something that was potentially not got much movement.
Man, and I made a video too. I showed that you can pull the line tight. This is over about 400 yards, and I just had
right.
Some,
And
30
and how did you check the line was straight?
Wanted to see, so
I
just wanted to see if you could pull it up out of the water. It was very easy to pull up out of the water. It was very easy, and it didn't have no sag in the air. At my house, it only had 3 inches of sag, not even pulled very tight, over 500.
That's in the air.
Yards.
That's in the air. If you do it in water,
right,
you're gonna get way less because it takes the weight off of the
way
line.
Less.
You're claiming you had a 400-yard line that only had 3 inches of sag.
No, 570 yards.
570 yards and only 3 inches of sag.
I've measured it with my auto leveled it.
Oh dear, can't use optics. Can't use optics, people.
But I didn't show it through auto level, so got to take my word for that. But I could do it again. Show that.
This is my point.
Level got stolen.
So you've got a video. So let me get this right, Brian. You've got a video in which you are hanging a line that's 570 yards long, and with an auto level, you've established that it was only 3 inches of sag. Is that correct?
Yes, look at 570 yards fishing line test. I wanted to see because they told me after 60 feet that it'd sag to the ground if it was a foot high.
Those sag calculators are
professional.
Bullshit.
Yeah, the math does not work with monofilament flexible line. I didn't even have it pulled all the way tight. I didn't snap it. I rolled it back up, but I pulled it over 570 yards from one telephone pole, like 4 telephone poles down my whole road, and I checked it with the
Did
auto
you fucking
level.
decapitate
and it was
anyone?
about 3 inches of fall. I could have went back and tightened it, but I just wanted to see if it made it that far. They said over 100 yards you couldn't get unnoticeable sag.
That's
We
very
noticed
interesting,
sag.
Brian.
You can't see the sag with your it is. You can't see the sag with your eye over that distance. It's a few inches, but I was like, okay, well, it's way better than they said, so it's worth doing the test. I just still haven't done the damn thing yet. But it's
All right, why did you use an auto level, Brian? Why did you use an auto level to check it?
We wanted to see the sag.
Because
Right.
I didn't think it was sagging at all. It looks perfectly straight to the human eye.
Yeah. Do we trust auto levels then?
Brian, right? 570 feet, right?
Oh yeah, I'm sorry, 570 feet.
Oh,
I'm sorry,
God.
that's still a lot, dude.
Right.
That's still a lot, Rumpus.
That's still far. That's still far,
yeah.
Brian. Yes.
Yeah,
But
that's
why do you trust the
Point
auto
is,
level
if
to
you
give
do-
you straight then?
If you do this in
No,
water with
no,
neutral
no.
buoyant, if you do this in water where the line's neutral buoyant, you're not going to have. You might have 0.1 millimeter.
Yeah, it's much reduced. I'd agree with you, Jamie. It's be much reduced. Yes.
Yeah, unless 10 birds poop in it.
But the trouble, unless they've got 10 birds on the go. But the trouble is, there's quite a big difference between 570 feet and say a mile.
Yeah, 3 times as much difference. But that's a long way, though, Rumpus. It's a long way,
I mean,
bud.
I can't. I'd have to go and get the saggy calculator. But you know, over the distance of a mile, I suspect.
No, those calculators don't work. Those calculators don't work.
No,
they're off
they definitely
by
don't.
a lot. They're not taking in elasticity of the line.
Well,
question for Brian.
They're
Brian, why did you
thinking-
use an auto level to check it?
Because he didn't
Because,
have.
man, I wanted
Ruhif's
to see
got
how
a-
much it was falling. It looks exactly level, but yeah, you know.
At
the
auto
numbers-
level,
looks.
Ruhif's got a
Exactly.
bonus.
This
level.
whole
I
thing,
did it
right?
over the-
This whole thing with you
I
guys
did
is
it over
trying
the-
to
I did it
avoid
over
using
the
optical
gra-
instruments.
No, I did it over the ground. No, long distance optical, Ruhif. Long distance optics. We know light does funny things once it gets a couple miles.
Funny things like bend predictably, yes.
No, okay, really. I mean, if
Yeah.
you want to
Let's
belittle
not
the
have the refraction
conversation,
argument.
Well, you guys are talking about laying fucking mile-long
That's why we're
slabs
doing
of
this
concrete.
test to get out of the refraction argument.
I mean,
We're trying to
Ruhif,
escape
he
that.
could claim this is just an approximation. He's just trying to get an idea using what he regards as a flawed system. So he's got some sort of justification for doing it because he didn't really have any other alternative. But yeah, it's flawed.
Yeah,
It's
I
going to give you
haven't seen-
approximate.
Yeah, I haven't seen anyone give
but
a
I didn't
good...
do it over water.
It doesn't matter whether it's over water. It just has to be above the surface, a decent amount above
Well,
the
if
surface.
it's over water, man, if it's over water, I could have seen how much it was sagging in the middle versus the end. I did the water test just to see it. It didn't sag any at all, but that was only over about 100 yards, maybe a little over 100 yards. And
My
I
advice
just
to you
wanted to see
guys
if it'd pull up
would
out
be
of the
to
water.
actually measure the refraction.
Now, because Ranty had trouble in the pond when he did a long stretch. He said it was kind of hard to pull up out of the water. But I just wanted to see how hard it was, and the line I had, it came right up out of the water. No problem. I'm looking for it down at the bottom, and the whole time we had it pulled up as soon as we pulled it tight, but we didn't sink it too low either. We only sank it down a little
when
bit.
you say they suggest them measuring the refraction, are you suggesting using a reciprocal zenith thing?
No, actually getting like mini weather stations to measure the temperature and pressure.
The Globers aren't
And
leading
then
this
using a
conversation
calculation
into
to work out what the
refraction
refraction
nonsense.
is.
Yeah, we're not going to
Hello,
talk
is
about
my mic-
refraction. The whole point of this experiment is to get away from refraction. Literally. So it's not even a variable.
Mic check, mic check. What's going on, everyone?
What up?
What's up, Matrix? We're not taking pictures of our own ass tonight.
Okay. Oh well, if you don't care about refraction, there's not much point.
We're not. We don't care because we're not doing a test that involves refraction.
Yeah, but you keep suggesting tests that you cannot demonstrate that something's
Measurement.
straight. Like Brandon
I
said half an hour ago.
I misspoke.
How
It's
hard is it to
measurement.
get something straight?
I misspoke. It's a
No. It's not that hard to get something straight. It's hard to get something that satisfies you all to demonstrate it. Because y'all got an excuse for everything.
Brian,
So, let me ask Rumpus this real quick. Rumpus, if I glue together PVC and I mark it right where I glued it, I mark it where it's touching the water, it's floating on the water. I mark the lines down it where it's floating on the water. I got them butted up against each other. And at the beginning, it's level. And after a mile and a half, let's just say they're all sloping down gradually about 2 feet, right? So I have every piece individually marked where it's touching the water. And then I roll them out away from each other, I roll them out away from each other, 90 degrees each. Just do a slight roll, and make sure each pipe is 90 degrees from its original mark. Every mark on each pipe is 90 degrees from its original mark. Shouldn't the ends deviate away from each other? Or could you tell me a way that the pipes could hold mark and not deviate?
Yeah, how are you going to check it?
Right, so the pipe, well, I'll come to that in a second. The pipe thing is it's rather similar to the idea that I mentioned a couple of days ago. If you lay the pipes such that, and make them neutrally buoyant in some way, such they just float on the surface of the water, then that would indeed then have the shape of the water. And then if you glued them together, or bolted them together or something, in that shape, then that would then be semi-rigid. It'd be much more rigid than the line.
Right.
And
it could still bend downward, right?
Hold on. And if it was you made it neutrally buoyant, then you could indeed
the fishing line neutral buoyant is straight.
Yeah. Well, no, you're assuming that. You're assuming you can pull it tight enough to do that. I don't think you can. But I'm just saying, if you had the pipes and you made them neutrally buoyant, so they just floated in the water, they would adopt the shape of the water, and then you would be able to rotate them. Well, that's a question, actually. If this is a mile-long set of glued-together pipes, if you start twisting one end, but it's certainly semi. Hold on, let me finish. Finish.
Would be a way?
A few more seconds, Brian. A few more seconds. Come on, Brian. Can I just finish my sentence? So if you've got these rigidly connected pipes, which you could bolt them together or something. Oh, come on. Can I just finish my sentence? So if you bolted them all together and they've got the shape, then you could rotate them by 90 degrees. And then you could do what Brandon suggested originally with that shape and was in the diagram by Pebble or whatever it was, that you then, the usual, butt them together, and then you would be able to see they were varied. But if you have them suspended in the water, then they would retain the shape, and possibly you might be able to rotate something even a mile long if it's neutrally buoyant. Go ahead, Brian.
Right, I must be lagging, man, because I wasn't trying to interrupt. I must be lagging a little bit, but
well, a lot. You interrupted quite a lot. Perhaps I was going
very
quiet.
Sorry, man. I actually wasn't trying to, pal.
That's
but
okay.
Here's one other thing is if the pipes are touching each other and we bend them each 90 degrees, we mark them on top and we mark each individual pipe. It'd be tedious, but if we bent them over 90 degrees to the right, they could still bend downward with the curve. If the Earth is curving and they bend downward with the curve, that would not take away from the deviation at the end. You see?
It'd be bending at a different axis.
Exactly. That's why I think you still haven't got this idea, have you, Brian? You need to rotate them around one axis, which you can do if you have them held rigid.
Right. That's why we check every line, every mark. We check every mark on every piece of PVC to make sure they
But why not just bolt, Brian? Why not just bolt them together? Why not just bolt them together so the whole thing's rigid?
Well, once you glue them together,
or bolt them. I'm saying, if you bolted them together, then you really would make sure they wouldn't come apart.
Yeah, we could brace them. We could bolt them, brace them, and glue them.
Yeah. Okay. Both. Yes. So once you then
can I say one thing and then go?
Go ahead, Riff.
I think anything that involves something physical is going to have mass, and then it's going to be affected by that force that affects masses, and it's just going to be inconclusive.
The neutral buoyant line.
That's why we're using the buoyant
line.
Yeah, and like I said before, the neutral buoyant line is only approximately neutral buoyant, so it has mass, and it'll have an equilibrium depth in the water. Anything that has mass involved is going to be affected by gravity. It's just going to be too hard. Therefore, use light.
Right, Ruhif, but do you not accept that if you did have a series of neutrally buoyant pipes, that they on the surface of the water, that they would follow the shape of the water? I'm not trying to draw a straight line.
Yeah.
I'm not trying to create a straight line. I'm just letting these pipes follow the surface of the water because they're neutrally buoyant or very slightly positively buoyant, and then you could just link them together with bolts or glue or whatever you want, and then it's just a matter of then turning them on their side, which you might be able to do because it's a mile-long thing, so obviously it's still basically probably impractical, but you've got a fighting chance if they're just neutrally buoyant, these pipes, and then you're just rotating it by 90 degrees, and then, I don't know if you've seen, he's just going to make them touch somewhere, so you need two of these things, and then you
can rotating? I don't get the rotating on the side. What does it mean to rotate on? What does it mean when you rotate them on the side? What does that mean?
Right, so imagine you've got the curve.
Roll over 90 degrees.
Yeah, just simply turn it by 90 degrees so that they're no longer, the curve is going 90 degrees to the, following the surface of the water then. Should I draw a diagram? Well, did you see the diagram?
Draw me later.
Okay, but basically just imagine you've got a hoop, and then you
let's
just lay the
bring
hoop
the
on its
diagrams
side.
out.
Lay the hoop on its side. So imagine a croquet hoop, Ruhif. If you just laid it on its side, then you would then be able to, and you had two hoops, and you could then compare them, and then you could see that without needing to build a straight line, you would see that the gap at the either ends was much bigger than the middle if you made the middles touch. Can you see that?
When you say rotate it,
imagine a hoop, imagine a croquet hoop sitting in your lawn, and then rotating it just simply to lay it down on the lawn. So to push it over.
So, sorry, it's standing up like on its edge.
Yes,
very
exactly.
balanced.
That's what it would be doing in the water. Effectively, you'd have a hoop that's following this curve of the Earth in the water. It'd be like a croquet hoop, but obviously be much flatter. And then you just need to compare it with another hoop. You need to lay it down on its side, and then if you've got two of those, then you can sort of overlap them or make them touch, and you see that they will not be straight because there'll be a gap at either end. So it's just a matter of two hoops.
For some reason, I cannot visualize this. We'll do it later.
Rumpus, we should draw a diagram. Let's start drawing
two hoops,
stuff.
croquet hoops, and you lay them down on a lawn, and you'll see by the fact that the ends don't touch that there is a curve there. That's really all it.
Yeah, Roof, you got two 5-foot high little arc bridges. They're 5 foot off the water and 5 foot or 10 foot apart. Just push them in toward each other, where the tops are touching each other, but the ends ain't. So what we're trying to do is put two things together to see if we could see the spread, because we think that there's going to be no spread, but we're trying to come up with something that satisfies both sides, and we're close to a couple ideas that may be practical. My whole point is that if them pipes if they come apart and we can't twist them 90 degrees, then what would happen? The marks would have to come off. If they come off at the hinge, so them marks wouldn't line up. It'd be tedious to check all them marks, but if they lined up and the Earth's curvature, we should see it.
Yes, I mean, you could argue that if you did rotate it and then something broke or twisted, then, because if it probably twisted, it might break, but at least you'd see where they should be, because you'd have the original drill holes for the braces or whatever, or the marks as you put them on there, so you could see where it could be. So I mean, you could almost actually break it in half or break it into, as many bits as you like. You could actually break it into 100 bits and then rotate each of the 100 bits separately, and then you could brace them all together, following their marks. And
you
then
like this? Are you with this, Are you with this, Rumpus?
I'm still thinking back as this is the equivalent of the laying a mile-long piece of concrete and trying to rotate it, trying to actually.
Yes, that's right. It's like that.
No, because this one we can break up though.
Yeah, well, would it? Or would it just bend?
On a flat Earth, it should roll pretty easily. With a bunch of people, with about 20 people to work their way down. But it'd be tedious to mark every piece. But for me to be satisfied, we'd have to mark each individual piece.
Again,
can I clarify just to see if I understand the idea? Because maybe some people in the audience are a little lost. So you're talking about getting these neutrally buoyant pipes, taking small sections and attaching them so they float on top of the water. And
so you make them neutrally buoyant. So they're just plastic. So they're almost neutrally buoyant. But you could put something on the side of them just to make them very slightly positively buoyant if they're not
floaties.
They're not.
And then
put some floaties on them.
Okay. And then hold on. I'm almost done. So then you'll mark them somehow.
Well, join them together.
Join them
together, or mark them together. Whatever. Yeah, you could use a mark, or you could brace them, and then you could see, and then you could just brace them, mark them, and then you could actually break them, take off the braces, do the rotation, then re-brace them, or just line up the marks, whichever. I prefer the idea of something solid, but you could then unpick the braces, so you could, for the rotation part, it doesn't matter whether you rotate them all together or just in pieces, providing you can then line them up afterwards.
If you can line them up, if you have marks that they can only go together because of these marks, maybe you even drill holes into them so that they can only line up.
Drill a hole straight through it.
That's what I'm saying. Join them with braces.
Drill a hole. You put nuts and bolts. And bolts.
That's what I'm saying. That's what I'm saying.
Yeah, we brace it off. Yeah, we need fasteners for sure.
Yeah, but you don't have to roll it all as one.
They all turn exactly 90 degrees, then it'll
take this apart and reassemble it. Like the Rumpus said, you could take this apart and reassemble the shit later.
Yeah, that might work.
So you don't have to rotate it all in one go, which will, always be problematic. So you can rotate, 100-foot sections or something.
So
which will definitely be possible.
How about something different?
We can go 9 miles with this.
Wait, what's up?
How about a very long vacuum tube?
No, then we've gone down that road and we end up recreating LEGO. Hey, Ranty, what's going on?
Your vacuum tube.
Hey.
I'm out. See you later, Ranty. See you too.
See you later. Right, listen, I was just thinking, what if you could get like 100 meter, 1 mile of UPVC downspout, you know, for what you put on gutterings, and you just float them and line them up piece by piece along a whole mile, and all you'd need is a camera at the one end just to look through, just to see whether or not you can zoom through to the other end, and as long as you can see light at the other end, that's it.
Yeah,
we
didn't
talked
somebody,
about that the other
who was
day,
it?
and the thing that we discussed was, well, okay, well, what if whatever is happening with light that we're calling sinking or looming or whatever, why isn't that going to happen inside the pipe? There was quite a bit of contention about that. So you're still dealing with the possibility that there's refraction impacting it, but in theory, yeah, I get you.
You see, obviously, you know, I mean, Rumpus will talk about heat and, you know, all this kind of stuff that's affecting, you know, what we're seeing. But we, as flat earthers, know when we get out there and we do these observations that a lot of it's down to the humidity and the evaporation that's happening across the water. Well, obviously, removing that by having it enclosed in a pipe is just going to give you just the optics, you know. That's it.
The optics are refraction. It's because there's a density gradient and it will refract.
So, you know, this is, you know, this is the argument that you come up to, isn't it? So you just can't get a pipe and look through it and see whether or not you can see it.
No.
But I mean, put it like this. But actually, that would support it, because I know that won't. You know, you would not be able to see the other end, even with refraction making it flatter. It wouldn't be enough to compensate, because the refraction that you experience at that level is only 1/4 or something of the actual bending of the Earth. So you wouldn't see it. So I can guarantee you that would actually work as a test that would satisfy me, because you wouldn't be able to see the light at the other end, because it would be bent and the refraction wouldn't compensate for it. So if you were to see light at the other end, that would be quite convincing, because I don't believe even with refraction, the refraction, unless it's unusual day and you've got some strange effects, if it's normal standard refraction, that is less than the curvature of the Earth.
We take a day where it's refracting the way you say that it bends light down, and then we take a day that's bending down and up.
That's a normal day.
And then we just take a mile and a half foot of pipe with the light at the end, see if we can see the light at the end.
Just following the water, following the water.
We shouldn't even see the light at the end. We shouldn't see the light at the end if we get it straight, but that'd be tough.
So essentially what you need to do is find a frozen lake. That's it. Just find a frozen lake. If you can get a mile of pipe or a mile and a half of pipe UPVC, second hand, it doesn't really matter. Just get 20 guys out there just to attach it piece by piece along the entire mile and a half stretch. Stick your P1000 at one end of the pipe in. Look through it. Can you see light at the other end? Job done.
Well, it doesn't need to be a frozen lake, providing you can suspend this pipe on top of the
water.
Hold on,
right? Providing it floats on the water, you're away.
Hold on. What was wrong with Leaky's things as far as the non-optical thing? Are we good with that, Rumpus, or what?
Well, I mean, you're talking about my suggestion of the pipe and the rigid bonding the things together. That would work.
We bolt them right through. We could disassemble it later, put it back together on the beach or something.
I really like that idea. I mean, I really think that is actually doable.
Idea to use 6-inch PVC, man. He's trying to grease in on my.
Rumpus gets all the credit for this. All right.
No. Brian was the one who suggested PVC, but I did suggest something neutrally born you could rotate many days ago.
I'll share it with you then, Rumpus.
Yeah. Okay, we'll go with it, Brian. We'll take a joint credit. But yes, but the trick is you can provide the marks line up. But the trouble is those marks will have to be incredibly well done. You'd have to make sure they come back together really well. That might be a bit tricky, but at least it's semi-practical. I mean, I'd have to think about just how well you'd have to. But then again, you see, by joining them together, providing you put them back exactly the way they were, you're not measuring it against something. You're just drilling it, and then you're bolting it rigid, and then
we're going to make two of them.
Yeah,
we'll make two of them,
rigid,
and then we'll have something to measure it against.
So that, in other words, if the holes you use to bolt it together, or I mean, if you glued it, you see the thing about or the marks. I mean, if you made the marks, you see those marks have to be. Yeah, but it's still, yeah. If there was a random error,
we drill holes? Can't we just drill holes through them and put bolts in?
Exactly.
Yeah, exactly. Yeah. But the trouble is, if we're dismantling it, you then have to make sure that the bolts can't wiggle in the holes. You see.
Right.
So you do have to be careful.
We're going to get a drill bit size, the same size as the bolts we're putting through. We know how drills
but, I mean,
and bolts
the
work.
accuracy you might be, I'd have to think about it, but the accuracy required might be extraordinary, but it's certainly nothing like as extraordinary as Brian Mullen's thing about forcing the line.
Let me address what Ranty said. All right, let me address what Ranty said earlier, though, about the optical thing. There's a thing happening in the air that's making things appear to sink. They say refraction is...
No, it makes
they say
rise
refraction.
up. Not sink, rise up.
Can you just stop for 1 second, please, Rumpus?
Okay.
Now, they say it's looming, which goes against us, but really it's sinking, which is what we see. So whatever is happening outside, I think, would be happening inside that pipe.
Yes, it would.
Yeah. Yeah, that's the problem with that. But this
That
is
would
the way to make sure that you can align these sections of the pipe back again. We can play around with that idea because we could do all manner of stuff. We could drill the hole.
We could do both.
We could drill. We could also mark them. We could fucking spray paint the top. Who knows? We can come up with all kinds of ideas for how we do that.
You could do both. But once you've constructed this pipe, you could look through it, as Ranty suggested.
Yeah.
And then you could do this dismantling and turning it on its side and do it. So you could do both. But it's established fact, Jeremy, that the refraction is causing light to bend down, which makes things
we know.
loom up.
Okay, so would it be a problem then that if we did it on ice, Rumpus? You know, would it give extra leverage to the flat Earth if we did it on ice and we were able to see through the other end, or would it give more leverage to you guys?
It would make it look. If you're on ice, you do tend to get more looming, and if the conditions are really tricky, it can give circulating rays. But most of the time, if it's a normal conditions, I mean, for instance, if you did it with George has got this observation. He's looking at this target in the distance, and he can tell you exactly what the refraction's doing on any day because he knows the position of this target.
No, because you use refraction to match to the globe model. That's why he knows what's happening
he can
on
tell you
any day.
Not
because you know how the light's bending or what's happening in the atmosphere.
Yeah, agreed.
You match it up to the globe model and say this is
but nonetheless,
light's bending. Rumpus!
Yeah. Well, you interrupted me actually first.
Talking all the way through me. Oh, my bad.
Well, actually, you interrupted me, if you remember.
All right, my bad. Go ahead.
So George can tell you, and he does indeed base it on the curvature of this, but nonetheless, he can tell you on a different day where it's going down or up or whatever. So he could actually tell you. But yes, in principle, Ranty, you're right. It wouldn't make any difference whether it was on ice, if it's reasonable conditions on ice or on water. It would be fine in either case, probably, yeah.
Okay, and one last thing, which is that if we did it in a pipe and we had a 1.5 mile stretch of pipe that we were able to see through from end to end, we would be eliminating one of the variables that flat earthers say is the reason why we see things disappear from the bottom up, which is the distortion that we get from the evaporation and the cold mixture of air and etc. Right above the water, right above the ice, we get that denser area there that seems to affect things when we see things disappear from the bottom up. So if we had a solid pipe, would that, well, obviously that's going to eliminate that. So that would be more beneficial, I believe, for flat earthers, right?
Yeah, I mean, it's not an effect. There's no effect.
I said a variable.
No, it's not a variable. It doesn't make any difference. But maybe
of course it's a variable. If you had 10 kettles and you tried to look through the steam that each 10 of those 10 kettles were producing, would you be able to see through whatever they were producing?
Okay, if you had, it would attenuate. It attenuates the light, but it doesn't bend it.
So it distorts stuff?
No.
Yes, really. It does. Come on, Rumpus. Don't be a dick.
No, you don't understand how refraction works.
Magnified.
I mean, if you want to worry about that, it's not an issue. The humidity does not affect refraction.
That's fucking bullshit. That is a lie.
Say humidity.
Fucking
How
lie,
can you
right?
possibly say humidity doesn't magnify on some days?
No, it doesn't do
surveyor hold on, Rumpus. Why did the main surveyor take humidity measurements for his fucking refraction measurements and plumb lines aren't parallel then?
I don't know why he's done that.
Fun? Well, you've already established that those measurements are bullshit, but I'm wondering why he took humidity measurements.
Well, I don't know. I mean, there might be a really tiny factor, but it's so insignificant compared to the other factors.
Doesn't refraction of water and the humidity in the atmosphere make a rainbow? That plus perspective make a rainbow look bent down?
No, hold on. That's not water vapor. That's water droplets. That's something completely different. You're talking about water droplets for
Okay, would you say that 100 feet of water vapor could possibly equal 1 drop of water? I mean, we're talking about over distances, man. I'm just trying to get you to open
water
up your
vapor is a
mind
gas,
and
just like
consider
air,
it.
and the refractive difference is very
Like
small.
a cloud, right?
It's
Like a
very
cloud. You're not going to see.
Clouds
are
are
thin,
not
Rumpus, you can see
water
through 'em,
vapor.
right?
They're droplets. Cloud is not water vapor. They are droplets of water suspended in the sky. It's not a gas.
They're in the sky, are they not?
Yes,
Damn,
but they're
dude.
suspended.
Okay,
They are
then.
water droplets. They are not water vapor gas.
We're getting distracted from the main issue here. Let's try to bring it back a little bit.
Yeah, so the point of the humidity is not an issue for me at all. It's a tiny effect,
That's ridiculous.
if anything at all. So, but if you want to worry about it, you can. As far as I'm concerned, you can ignore it.
So I'm thinking that
You're worried about
looking through the pipe
birds pooping in my
optically would be
water.
a secondary test.
Yeah.
You know, the primary would be following the shape of the water and turning this thing over and measuring the deviation, physical measurement.
Yeah. It certainly wouldn't do any harm.
The humidities. You're talking about the humidity. Humidity is insignificant, but you're worried about bird poop.
Yeah.
Yeah, I know.
It's
10 birds.
insignificant, Jeremy.
All
You
right.
ain't got much
Okay.
common sense, bro. You ain't got much common
No,
sense.
you're not familiar with the scientific work that's being done on this subject. I can show you the formulas. For instance, the amount of carbon dioxide in the air is 10 times more important than the humidity.
Guess what, Rumpus? If the Earth is not curving the way you say it is, then their mass is it matches a globe. I understand they got formulas. They got a formula that matches the globe. I understand that. But if it's not curving out there, then everything just got 20 times more complicated with refraction.
While we have the pipe set up, we could look through it. But after we look through it, we should bolt it together and then go back to the beach and assemble it.
Yeah, that's what Brandon's saying. You do the two things. Yes.
Yeah, do them at the same time.
Does reassembling the pipe work for you?
Well, I would have to think about I'd have to go and I'll probably go better to go and talk to George about what, because you're going to attach it together and you're probably going to have to attach this thing with an accuracy really, really, really accurate. But I mean, the fact that you've drilled it together, I mean, it's not like you're trying to measure it with a ruler. You've actually done the thing.
Screw it.
And providing
We're
you
gonna
don't
get Rumpus.
you know,
we're
if you
gonna
sort
get
of
bolts.
glued it, you put lots of marks. I mean, you
We're
really
gonna get a drill bit. Hold
yeah,
on,
exactly.
Rumpus.
But that's but I could drill a hole in something, then put a bolt in, then take the bolt out and put it back in, and it could be different by a millimeter.
No, we just use tapping screws, guys. We use tapping screws. If y'all want to do that, just put a couple tapping screws in it. But we need braces either way.
Yeah.
We need to brace it. Each extension we got to brace it. But if them braces don't flex, then we're in business, man.
I mean, the thing is, don't forget the difference over 100 feet, the bending. The angle of this pipe, whatever, is you know, minute fractions of a millimeter. But the fact that you're talking about the rotating and drilling it back in, I think that really helps. But it may still not be accurate enough. But it certainly gets a much more practical. It's, for instance, this is 10 or 100 times more practical than the forcing the line thing that Brian Mullin was suggesting, where you had to get which you need to get an atom solution here.
Can I get a minute?
So
could I
understand here?
Forget it.
Hold on, I heard you.
Can I just get 1 minute with the Rumpus? Just 1 minute, and then I'm going to step away after that. So, just two questions, Rumpus. So, if you was to evaluate Ruhif and his experience in optics and stuff, how well would you say Ruhif conducts his and knowledge is?
It's quite good. He follows Thomas Young. He's actually modelled refraction in a primitive manner compared to the stuff that I've done, but he's understood the principles. So he's generally very good.
So if I said to you that just 2 minutes ago, Ruhif posted in the general chat on Discord, I agree, refraction is affected by humidity. That's in the formula.
Yeah, it's a very minor effect.
Okay, thank you. I'm out. Cheers.
See you, Randy.
Very good, man. Let me explain this real quick, guys. Hold on, my turn.
It's in a formula, but it's negligible in comparison to the other effects.
So everybody understands this. What we're doing is we're gonna link together.
So your points are validated, Ranty.
Hold on. Over 1.5 miles, we're gonna link together the pipes, okay? And we're gonna mark them. They're gonna float on the water, and we're gonna mark them all. And then what we're talking about doing is disassembling. We're gonna mark it where they're exact. And then what we're gonna do is put some self-tapping screws in to link it. And then what we're gonna do is detach it, like in about 20 pieces. and then turn it sideways and line it back up to where they're twisting it, which I don't think it'd mess it up anyway, but just to be safe, to make sure that the turning it 90 degrees while it's floating doesn't knock it apart or stretch it, or we're going to take it apart, turn it sideways, and then reassemble it. And we got it, folks. Eureka, motherfuckers!
Well, let's kick this around for a couple days in your head, and then the next step would obviously be to do some proof of concept on a small scale.
I mean, what you could do, obviously, if you had the opportunity, if it was floating in this trench that was just needs to be about a foot wide or so, 2 feet wide perhaps, you could try and rotate it all together. Then you would avoid the problem about the accuracy that I was talking about of dismantling it and then reassembling it, which is potentially problematic.
I agree. We try that first.
So that's what I mean. If you make the bolts so they can barely fit in the drill holes, so it's tight. There's no wiggle room. There's no wiggle room.
Jeremy, we're talking about an accuracy required.
No wiggle room.
Yeah, but we need to be able to reassemble.
Of a millimeter, Jeremy. We're talking about accuracy of a hundredth of a millimeter here. Probably.
Okay, and if there's zero room for these bolts to move inside the holes because they're too small, we gotta punch them in with a hammer.
You've never done anything to an accuracy of a hundredth of a millimeter.
We can play around with different methods for doing that. We can figure that out.
But the point is, if you could keep it rigid and try and rotate it all as one body, that would be best. And it might even be possible.
How about this? We run the bolts straight up and down with a plumb bob. We bolt them while it's floating on the water. We bolt it from straight up and down, and we go from the top all the way through to the bottom, right? And then we turn the bolts, basically the bolts that are going from the bottom through the middle through the top, that are sticking out like about a half inch, top and bottom, or an inch or so, and then we turn them 90 degrees. That's what we use for our marker.
Well, hear me out for a second here. So I know Rumpus, your idea is to do the whole 1.5 miles, attach it, and try to actually rotate the whole thing together. I think that's going to be extremely, extremely difficult. But if we're okay with disassembling it, if we can come up with a method to get it exact where we can put it back together exactly as it was in the water, we wouldn't even need to dig the trench 1.5 miles potentially. We could just do it, say, for 100 feet and attach it section by section, push it down, make the whole 100 feet, take the end piece. Hold on. Take the piece off the end and then add another one, push it down.
That's exactly what you can't do.
Why?
Brandon,
Why?
Yeah, I agree with Rumpus. I'm sorry, but
why?
I've got to, because each piece needs to be
because you need to join them together.
The same as the other.
Yeah, we will join them together. No, you guys are maybe misunderstood. We will join them together.
No, we understood you perfectly. You're trying to then do what Brian Mullen did, and to try and join on things that you fit together. And then you need accuracies within atomic accuracy, or 100 times the size of an atom. By having the cumulative thing and letting the thing all settle by itself, you've got the whole effect. If you start trying to join things together, joining them at the angle you think, you will get it wrong.
The angle you think? No, we're going to measure the angle.
Brandon.
No, look. How are you going to join one thing to another? You can't do it accurately. You'd have to do it to the same thing as Brian Mullen was trying to do, and say you'd have to get it within a resolution of, atomic accuracy, and you can't do that.
Maybe. What's up, Carlos?
Brandon.
Yeah.
So so you said that it wasn't a good idea to turn this structure 90 degrees while it's all put together. Is that correct? You said
I think we turned it.
I didn't say it was a good idea. I just think it's going to be extremely difficult.
Yeah, it's
difficult. Why? Because it's hang on.
But it is neutrally buoyant.
Well, I'm just saying, like, if the reason why it might not be a good idea or hard because it might flex when you turn it on that axis, well, that reason. Because these materials are not as rigid as you guys think they are.
You broke it up.
No,
Carlos.
we expect it to bend, bro, but it's not going to prevent.
Let Carlos repeat. We broke up. Brian, let Carlos repeat what he said. You broke up, Carlos.
Yeah, I said that the same reason why it may not be a good idea, or it might be extremely difficult to turn it at 90 degrees without taking it apart, is the reason why this experiment is not a really good idea, because these materials are not as rigid as you guys think they are.
Right,
we're talking about
the marks would necessarily.
Oh.
Go ahead. I'm sorry.
Go ahead. Well, go ahead, buddy.
If the marks lined up, it would necessarily have to be where it was to begin with. if
Right,
the marks line
they
up.
it could still flex though, Brian. Yeah, I mean, Carlos, you're
Yeah,
right.
it's correct, but we don't care. We expect it to flex. If the Earth is curved, we expect it to still bend with the water. It's still going to be floating, but it's still going to keep that curve. It's going to maintain the curve that we
Thinking
we
about
built
this,
into
Brian,
it.
you could twist one end, and it may not twist the other end at all, and it would just flex in between. So what you
Yeah,
could
that's why I
do,
say we need about 20 people to turn it
yes,
at the
exactly.
same time.
That's the key thing.
Would you agree with this, Rumpus? This is out of this.
You need to
Would you
rotate
agree with
it
this?
all
Would you
together by
agree
having lots
that
of
if we-
rotating things.
Right. Would you
I
agree
like
with
the
this,
idea
Rumpus?
of taking it apart.
Hold on, this is important. This is very important.
You
if
could
we
do,
turn it,
you could try
hold on,
flex
if we turn
you
it,
could try
if
to
we
origin,
mark
then you
it,
could take it far
listen,
back
Rumpus,
before.
this is a question for you, bud.
Yeah,
If we
Brian.
turn it, if we mark it, every piece we mark, and then we turn the whole thing 90 degrees before we even check it, okay, if the marks, if for it to not bend, would you say that the marks would have to be off somewhere?
Well, you could, in theory, have twists that the marks will still be there, and it could just flex in the middle. So it's problematic. But you know, you got a. The point is, you've got a fighting chance. It seems, except that we're talking about. Certainly, if you dismantle it and bring it together, I'm trying to think of what the resolution would have to be, and it might be just too demanding. If you're going to try and reassemble, because the accuracy, even if you drill a hole with what you think is perfectly to aeronautical accuracy, we're talking potentially about hundredths of a millimeter accuracy you need to do it. But you could try and anyway rotate it. Hold on, you could try and rotate it all together. If for some reason that's difficult, and you could see there were stretch marks or things were flexing, you could then take it apart and try it the other way. So there are layers of things you can do to try and give you a fighting chance.
Okay, Rumpus, have you ever drilled a hole in anything? Have you ever used a drill?
Yes, I have built numerous things, including my
Have you ever put a wood?
testing.
Okay. Have you ever put a wood peg in something that was too small for the hole?
Yes.
Yeah.
Yeah, where you got to pound it in with a hammer. Yeah, right?
Yes.
Is there any wiggle room in that, or is it fit perfectly?
Right, and now if you take it out and bang it back in again, it will not be in the same place.
Yeah, actually, there would be wiggle room. There go you being able to bang it in. It's a very non-rigid material, wood. Dude, if you take a 100-foot I-beam and you secure it on one end, with your hand, you could probably flex it on the other end several inches.
Yeah,
but we're going to disassemble
rigid
it.
materials are not as rigid as you guys think it is.
Yeah.
That's why this experiment is going to be a waste of time.
That's why I like the buoyant line. I still like the buoyant.
Jeremy,
or
you do know that skyscrapers,
buoyant
for instance,
line.
something like the Empire State Building, something like flexes, I think, is it 2 feet in the wind? So this stuff that seems to be rigid, when you have lots of length of it,
I hear you.
But the point is, you avoid the problems. If it's suspended in water, then you remove all these stresses. Well, not remove it, but if you knew, and as Brian was suggesting, that if you, and I was also that if you had multiple people trying to rotate each bit together, then you remove a lot of these individual stresses, and then you might have a fighting chance of, if you see afterwards all the marks still line up, and you could draw a mark, for instance, along these 100-foot things, some mark along the side that you could work out that was exactly straight, and then you could see whether or not they remain straight, so you could see if there'd been any flexing. So there are all sorts of ways of trying to check that you rotate. But if it did have a problem, then you could dismantle it and put it back together again. But the accuracy with which you have to put it back together again could be, as I say, hundredths of a millimeter, micron level, potentially. But I'll have to think about that properly. But it's certainly, if you're suspending it in water, neutrally buoyant, you've suddenly got much more chance of a success than zero.
You don't like the neutral buoyant line?
No, the neutral buoyant line, that's too flexible. At least with these PVC pipes, they only have to be rigid rotationally over a distance of 100 feet or whatever.
Hold on, let me ask you one thing about the neutral buoyant line, then I'll drop it. Let's say we get a 400-pound test line. We get the scale, we get the winch. We put 350 pounds on it. It's almost perfectly neutrally buoyant, but it sinks a little tiny bit, which helps you, by the way. But we take our measurement. We take our measurements. Then we go to the middle and we pull it down. And then we let it go and we measure it. And then we pull it up and we measure it. And then if those measurements are all the same, would you agree that the line's straight or no?
I must admit, I mean, if you did that sort of thing, that would certainly be very interesting. And if you could demonstrate that it really, if you found some really still water and you could move the line up and down and it came back, it restored itself, at the tension you can put, the maximum tension you can apply to it, and it actually came back to where it was, then you could say, it's. I mean, I don't think it'll work, but it's not. I think the tension.
The only reason I haven't done this yet with my 1,500 yards, which is almost my preliminary. The only reason I haven't done the preliminary with the mile, almost the mile line that I do have, is because I can't find nothing. The couple times I had help, there's current.
It's because you're lazy, Brian. Don't blame it on other people. It's because you're lazy.
If you guys would actually spend this time and effort to build something useful, if you actually build something useful, you might actually do some good for society. But instead, you dream up these things that are impossible to build.
I'll say use this time
I
to
haven't
see
muted.
a rocket launch in person. See if there's.
Listen, Brandon made me a mod a while ago, and I haven't muted anyone yet. But you're trying my patience.
I mean, I'm surprised that the Brian only got 3 inches of sag with his little thing. But try
it's because those sag calculators
for Brian,
are
that's a lot.
The sag calculators are fucking wrong.
Well, but certainly Brian will get
the
an enormous.
Are they accounting for elasticity of the line?
That increases the sag.
Go outside.
Elasticity increases
go
the sag.
And look at,
well, that's what.
Look at 5 football fields.
Well, when you stretch it, you can't just keep on pulling it tighter and tighter to remove the sag because you'll break it. And the elasticity
I could have pulled it tighter than it was, though, bro. It wasn't all the way tight, just so you know. And go out and look at 5 football fields. It was almost 6. It was 570 feet. Okay, so look at 5+ football fields and imagine a line that is dead straight over the.
A football field is 100 yards.
Yeah, I mean, you could try this, Jeremy.
I did 570 feet. So I did almost 6 football fields, and it was dead straight to the eye.
A football field is 100 yards.
Five football fields would be 1,500 feet, Brian.
Okay, God dang, why am I stuck on that, dude? So imagine that field. Imagine 2 football fields.
You guys need to speak in metrics for Trump.
It's too late. It's too late. I already debunked you, Leaky. It's too late.
Yeah, I mean, Jeremy, you can try this, but I mean, this is a suggestion made by some plain explainer about 4 years ago that I eliminated them. But if you can find some super still water, some super still canal or super still lake or super still trench,
we have this.
You could try it.
All water is still and tranquil because the earth does not move, Rumpus. Come on.
Rumpus, how still would water be? Pretend we got a 2-mile stretch at a beach, right? And we go 20, 30, 40 yards above high tide line. And we dig a straight trench. And then we fucking fill it with water from the ocean. And we filter it to make sure there's no little fish swimming around or turtles or bird poop. Right? How still would that water be on a day with no wind? A day with no wind.
The sand that you've just put it on is warmer than the water that it's in. It will have a little convection current, and that if every part of that line was subject to a tiny little convection current of warm sand, then causing the water to rise slow in a very, very slow circuit, it would still be negligible. You would not.
Okay, what if you do it at nighttime? What if you do it at nighttime when the sand's cold?
Yeah, that would improve things. Yes,
Then you have to worry about crabs.
Yeah, if you can.
Have you ever tried to build a moat in sand? Have you ever tried to build a water moat in sand?
We're gonna line the ditch with painter's plastic.
I mean, if you can remove the temperature differences, that would be a huge step forward.
So what do we need? The temperature of the sand and the water? I mean, what if we let the water sit in there for a day? And then we got the sand and the water is now all the same temperature.
Well, no, it's not. That never happens. That's why the sea is not the same temperature as water. They heat up at different. Heat up at different rates. The sand. So, for instance, if you were to go outside at night and go and sit on the sand or go and put your foot in the water, you would find.
That's their out. That's their out with this line, Brandon. That's their out. The convection of the ground to the water temperature is pushing the line up. Therefore, we're not getting the drop. That'll be their out.
But you could test it. No, but hold on. You could demonstrate this works or not. I mean, I'm saying what might happen, but you could physically go and demonstrate that I'm wrong.
Well, how would we know? Because you could always say no.
No. If you did what you suggested, if you had this line and then you got in, a mile-long line, and then you saw where it was, and then you pulled it down by a couple of inches, or pulled it up by a couple of inches, and it went back to where it was, and we could. I mean, if you told me where it was, I could do the calculation and say, yes, that is actually straight, because I could, knowing that the globe, I could actually tell you, yes, that is actually in the position for a straight line. So if you gave me the position underwater of this straight line, I could actually say, because I know the world's a globe and the rest of science does.
Yeah, you're going to go off the globe math and say, no, it's not according to...
I could tell you whether it's straight or not.
You're going to say it's not going according to the globe, the water curve, so therefore, no, it's not a straight line. Bullshit.
Well, I could...
yeah.
Well, I could... Well, put it like this: if you were able to get to the point where it remained going back to the same position, it would be.
We're done.
It could be.
Unless you're going to draw stuff.
There might be some way. There might be some way of working it out that you could show that the line. I'd have to think about it hard how you could do that, but I suspect that it will. That if you're trying to pull it straight, and that it will break. But you know.
You're acting like it's going to curve like a banana or something in there.
A banana.
You're acting like it's going to curve like a banana.
Yeah, you do know that the Earth is incredibly flat, and over a mile it only changes by 8 inches. That's not much of a banana.
Yeah, but if you're saying that even if we get it straight, you're saying even if we get it straight, according to the globe math,
it's
going to be curving like a banana.
If you got it straight, then obviously you've done it, and you will then see there's a difference. As you say, you'll find that it'll be underwater in the middle, and it will be much nearer the surface of the water towards the ends.
Rumpus, you already said, you'll know, according to the globe math, if it's straight or curving like a banana.
Well, put it like this. It would be interesting for me if you did this test, and I could actually then tell you from calculations whether or not it's straight.
Just to amuse you, Rumpus.
Yeah, I mean that's the trouble. But I could, if you did it, I could actually tell you whether or not it becomes straight. But obviously that's dependent on the premise that the Earth is curved. But it'd be very interesting.
So I could have I could have a perfectly straight line, but you'll say no, it's not straight. It's curving like a banana according to my globe math.
Well, no, I wouldn't go that. I would determine whether it's straight or not, but I wouldn't use that as the basis of an argument empirically against you. But it'd be very interesting to me, because I could then say, I could work out, if you gave me where you found your little string was, how far it was beneath the water, it would be very interesting for you to give me that measurement, and then I could say, oh, look, that is actually straight, which would surprise me. It would surprise me, but...
Go ahead.
No, I finished.
No, I was just going to say, the reality is that the difference between science and screwing around is just writing it down, right?
Yeah. Go ahead and call it.
No, we're going to end up having a perfectly straight line, and you're going to pull out your bullshit globe math and say, nope, your straight line's curving like a banana.
Even a straight steel beam is going to be curved if it's too long.
String line.
You're going to say your
line
straight
now.
line's curving like a banana because of my globe math. Bullshit, Rumpus.
No, I wouldn't. No, Jeremy.
Rumpus is trying to say that it's hotter at the top, so the string line's going to refract.
Look, guys, we'll do the experiment whenever Rumpus turns in his paper. How about that?
That's fair enough.
Well, I'm back onto that. I'm trying to put more effort back into that. But no, Jeremy, I wouldn't go. No, because I understand we're trying to do this empirically. So I'm not going to say because I know it's a globe, therefore you're wrong. But so I'm trying to find an empirical method, like I've done with the pipe, to establish whether something's straight or not. But I'm trying to find a way,
like they do with LIGO.
Yeah, exactly. Something like LIGO. They did that with GPS, which obviously I can understand from your point of view. You don't like GPS, and therefore you'll say no, that's not straight. But so no, Jeremy, I wouldn't resort to saying because I know the thing's a globe, therefore it isn't straight. But because I do know that it's a globe, it'd be very interesting to see if your line was in the right position, and then I could say, oh look, you did manage to make it to a straight line. But obviously that wouldn't be what you regard as straight.
If it matches the globe, you'll say it's a straight line. If it doesn't match the globe, you'll say I got a curving banana line.
No, if it's straight, it's straight. If it's not straight, it's not straight.
Yeah, but we don't. Yeah, but the point is, how do you establish that it's straight? That's the key thing. How do we do that independently of knowing that the Earth is curved? That's the key.
Because we're going to have neutral buoyant line, and when you pull it tight on both ends, the line goes where you want it. Therefore, it's going to go in a straight line.
Stuck in a sag.
Yeah, See, the trouble is, Jeremy, is that these things with little currents, whatever, and bird poop, it's going to be. I mean, I don't know for a fact. It could be straight. I think it's unlikely, but the thing is, if you could try a small scale thing of trying it across a couple of hundred yards.
How are we going to know if it's straight? Let's say we do 100
that's
feet.
The problem. I mean, you could using an auto level, and therefore you've got things like refraction to account for. You could at least say, we could make some corrections for refraction, and say, actually, well, no, you can't. You're not looking under. Oh God, I don't know. It's very difficult to make things straight. It's very difficult to confirm that it's straight. I can do it because I know
we can make a plumb line straight. We can make a plumb line straight.
We can indeed. Yes, we can indeed do that.
So how do we transfer that horizontally so we don't get a banana curve here?
Well, the fortunate thing about plumb lines is that we've got this thing called gravity working in your favour. Here, the gravity is working against you. Gravity's working in your favour for a plumb line. It's working against you in this experiment. So that's
in the neutral buoyant line. In the neutral buoyant line, it's the same thing. We're pulling it tight. You'll get the weight on the plumb line. The neutral buoyant line, us pulling it is the weight, and the line goes wherever you want.
But the trouble is this thing, for instance, going to be neutrally buoyant with the water you're using? I bet it's not going to be exactly right.
It's gonna sink. We're gonna make sure it sinks very slowly.
Okay, yeah. I mean, if you
sinking
did that,
helps you. Sinking helps you.
Indeed, it does. Indeed, it does.
It doesn't matter. We can add floats and sinks and get it exactly how we want it. We can manipulate them things, and it's not hard to make a straight line. It's just hard to distinguish a straight line between their damn globes.
No, it's very difficult to make a straight line. That's the point. How do you
I feel like no matter what,
if you pull a line tight, it's going to automatically be straight. Not up and down, but I'm talking about side to side. And if you hang a plumb line, you can't make it not straight, Ruffus, unless you just do something stupid to it.
Well, we've got George in here who's done some calculations and even got hold of a lot of line. He may have actually done something like this and tested the neutral buoyancy for all I know. He's certainly investigated this, and I thought he'd acquired some. So George might have some answers for you all here.
Oh, he's going to love this pipe idea, too. What's up, George?
George obviously not. But he's actually acquired some very high tensile strength monofilament line. And he's actually, I think he's done some experiments with
his line didn't have bullshit for test. I think he said 50 pounds or something. It's nothing. What's your highest test line, George? I can buy a mile of 200-pound test right now for like $300.
Okay, well, George is obviously not talking at the moment.
No, you can get for $100 for like $89. You can get 3 miles or like almost 3 miles.
Yeah, but mine was 200-pound test.
Yards.
Yeah, but what's the test on yours?
Hey, I don't think that. I'll tell you what. Before this stream ends, or the first thing tomorrow, I'll do my 80 and my 10 because it seemed like there was. It seemed like the 80 didn't do no much better than the 12-pound did, man. But I got to see for sure because I wasn't testing against each other, so I'll double check that. But it might be a waste of money. Once you get a certain size, it works pretty good. It seems to work just as good. But I don't know. Before we do that and spend the money, I'll do the test to see if the 80-pound I have, or I think I got 100-pound. I'll see if the 100-pound works better than the 12-pound, just to see. All right,
stop being lazy, Brian. Come on.
Hey, who was that guy down in Australia who did a similar test? I don't know if he was doing neutrally buoyant, but he had.
I heard about that.
Yeah, he had the line made, manufactured special for his purposes. And I believe it ended up snapping, if I remember correctly. I can't remember his name.
If he was smart enough to do this, I don't know why he didn't just use a fish scale on the side of the line to make sure he wasn't putting more tension on the line than the test was accounted,
Well, I don't remember how he did it, but he was the one that got, what's his name, Sensible to say, at most you've debunked the radius. I think it was him.
Oh, I thought that was for the Black Swan. That guy made that statement.
Yeah, I thought it was Black Swan, that statement.
Well, I think that's what they were discussing, but this was the guy that was having the conversation with him when he said that. I can't, Aussie something? Flat Earth Austin something? No. I can't remember.
No, you're talking about that one dude, oh my God. I went to say it and I brain farted.
Brian, Jesus, that guy can barely think.
The Australian dude, man, little good-looking dude with the blonde hair, kind of
Brian.
thing.
I don't know about all that, but yeah, okay.
Brian's gay.
Flat Earth Perth.
Yeah, that's it. Flat Earth Perth. Yep.
No,
get a scale.
No. I think you're wrong now that I say that.
Brian, get a scale. Brian, get a scale and put a scale on one end of the line when you're pulling it. So you know how hard. So you know how hard you're pulling it, so you don't snap the line. If you got an 80-pound test line and you only put 70 pounds on it, you're not going to snap the line because it's 80-pound test.
If you got 80-pound test, you're not going to snap it, bro. Period. You can't pull hard enough to snap 80-pound test without cutting your fucking
with a
finger off.
winch. If you had a winch or something.
Jeremy, one point is that if you do make this slightly negatively buoyant, we will be happy with the result, because either way, as you say, that favours the globe, and you will find that it will be under the water. So I'm happy with you doing such a test, providing the line is negatively buoyant and you don't have some excessive convection going on. I would be happy for your result. But the thing is, what you're going to do afterwards, you're going to say, oh, well, it did indeed sag. It was negatively buoyant. Therefore, you're not going to accept the result. This
doesn't debunk flat Earth. This just has a chance to falsify the globe. If it's thinking, we got all kinds of excuses.
Dude, the way my test set up, I'm going to find out which one it is, man. All I need is a centimeter of deviation, and I'm going to find out whether it's a globe or flat myself. But
Listen,
if it's a globe, it's going to pull downwards a centimeter at least in my test.
I'm after the truth, but it needs to be definitive. This would be definitively a way to falsify the globe.
Hey, it was Mitchell from Australia.
Over 3 miles. Mitchell from Australia. There you go.
Yeah, if you had a negatively buoyant line that stuck to the surface of the water.
Neutral buoyant.
Well, you said you were going to make it slightly negative, because what's going to happen, as I say, I'm worried about
slightly negative, yeah.
Slightly negative, just very slightly negative, and then hopefully you account for that by pulling it tight. But providing you haven't got a pool of water that's got the thing, some convection currents in it, and I don't quite know how to establish whether.
I mean,
you could probably take a temperature. You could probably take the temperature of the bottom, the temperature of the bottom, and the top and the bottom, and see if they were the same. Or
Rumpus,
something.
hold on. Could we? You're saying the water is going to be colder than the ground, right?
It can vary which one's which, dependent on what time of day it is.
All right, so we could either wait for a time of day to make it match or very close, or we could heat the water up. We'll get some blow dryers or something
like that. Though a mile length of water might be a bit problematic heating that amount of water up. I think you might be better off waiting.
We'll get a bunch of our wives with some hair dryers out there.
Yeah, I mean you could put a little element in there. So you could do. I suspect it's impractical, as is much of all this, but there must come a point where they go during the day where you would have thought that the water and the stuff around it, if it's only a narrow trench, then obviously it will absorb probably more likely, where something like the sea, obviously it's getting lots of other water from the ocean. If you've got a nice narrow trench, it might become...
The way you talk, we could just have you come out there and talk to the water and heat it up with all the hot air you...
I'm sorry, Jeremy, if I'm giving you lots of info and ideas. But
no, it's fine, you're good.
But yes, you would have thought there'd be a time of day. I mean, you could test this, of course. You could stick some thermometers in the soil. You could stick some thermometers in the water. And if everything was the same, then you say, yes, go, we've got it. Here we go.
What if it was off? All right. What if it was off a half a degree?
I think, I suppose I'd have to go and look at, I suspect that probably wouldn't make enough difference. But
what about 2 degrees?
Yeah.
Is this a fishing line? Is this the fishing line test again?
Yeah, George, I mentioned you earlier, George. You've done, well, basically, Jeremy's saying, is it reasonable to pull this thing tight if it's neutrally buoyant or very, very slightly negatively buoyant? Would it go straight? And I'm thinking it's going to snap, but he's, saying, well, what's stopping it?
Of course it's going to snap. You're not going to overcome the surface tension. Jeez.
Why is it going to? It's already underneath the water. It's already under the water. Why? What surface tension of what?
You could weigh it down, George, I suppose. Or
surface tension of what? It's already in the water.
Yeah, that's my idea, was weighing it down in the middle and just having a slight transition
and then release
as it goes. Over 3 miles, I hold it down 2 feet in the water over 3 miles.
We're gonna have a scale.
And then when before it snaps, if it nudges up, then it's trying to get flat. If it nudges down, it's trying to get globe. Period. It doesn't got to move but about a centimeter.
Okay, whoever's worried about the line snapping, we're gonna have a scale. Measure the amount of putting on the line to make sure it doesn't snap.
Yeah, but my point, Jeremy, along with George, is that you need more tension on the line to make it straight than it will take. But I'm thinking of
let's move on. I don't want to eat up the whole show. I don't want to eat up the whole show with this, guys.
Whenever I've worked through any scenario having to do with thermals, surface tension, sagging the line, you always get screwed because the amount of force goes as the square of the length.
I'm sorry to cut in, but there's no surface tension. There's going to be underwater, George. Underwater, brother.
He doesn't listen. He doesn't listen.
He does. George has done incredible measurement stuff. He used to have Tell me about your oil baths, George, because George has been involved in getting baths of incredibly close temperatures for equipment and stuff. George has been involved in getting things measured absolutely precisely, so he's familiar with all of these issues.
I'm not sure George can measure his dick, but let's move on because we don't want to eat up the whole show.
No, I'm fine. I'm fine with you guys doing the test. I wish you'd quit jawing about it and go do it. I've been hearing this damn thing for 6 months. Go and do it.
We're brainstorming.
Oh, you don't have a fucking brain to storm with.
That was a good one. I'll give it to you.
No, we got to make damn good sure that we're not wasting our time. We got to make sure that if we get certain results that y'all agree with them. That's the very important part of it, George.
Well, George has got a point about the surface tension. If the line started off on the surface of the water,
it's not. It's going to be underwater.
Okay, so if you make sure that the line. So, for instance, you could start off, as Brian said, you could put some weights on it initially to get it to be underwater, and then you eliminate the surface, and then it rise up to it, and then you would pull it tight from being lying on the bottom of this trench, and then you pulled it tight to lifting it to the supposed straight position. That would eliminate the surface tension issue, I suspect.
All right, well, let's keep kicking that around.
Let's see if George agrees with that. George, would you agree that eliminate the surface tension issue well, of course, the trouble is at the start, we both agree that it would actually be on the surface of the water, and that on the globe, it would at the very start at each end, it would actually be on the surface of the water. So you'd have to go. Is that pain there, George? Did you hear what I said?
All right, guys. Well, let's keep kicking it around. We'll talk about it over the next couple days. Just keep thinking about it. Think about the pipe one. See if we can come up with anything. I thought, White's word was going to join up, but I haven't seen her in the chat yet. But if you're still out there, we'll still make time for you if you still want to join.
Brandon, let George make a contribution. He's thought about this a lot.
You guys can let me finish a fucking sentence. I am trying to host a show here.
Okay.
But go ahead.
George, speak up. Oh, he's now gone on mute. Bloody hell.
Well, that's what happens, Rumpus. This is your fault.
George, speak to me, please.
What?
Oh, tell us why it's bollocks. Did you hear the surface tension line? If you lay it on the water first.
Yes, well, if you wanted to start with it submerged, all right. Pull it, give it some tension, and then put a weight on in the middle and, sink it and then release the weight. But that's only one problem. The biggest problem you're going to have are thermals in the water and eddy currents. I don't know how you're going to
covered. Rumpus is going to come talk to the water and make it all the same temperature.
Yeah, right.
Well, the idea was, George, they'd wait for a particular time of day so that the thermals wouldn't happen.
Or we could bring a heater.
Oh, come on!
Or
you cannot control the thermals over a mile.
We can't make water and sand the same temperature.
You've got to circulate the water. You have to create a non-laminar flow and get turbulence in the water in order to get it uniform in temperature.
So they could pump it presumably then from one end to the other, and there's another major job. But they could, in theory, then agitate the water and then wait for a particular time of day when the water and the sand could potentially be the same temperature. Could they not do that, George?
Dude, we could add sugar to it. How about we add sugar to it, dumbass?
Just a quick point.
Sugar to it, then make it curve.
George has dealt with baths. Was it 1,000th of a degree consistent? You had to circulate the water. So George has done
standards labs, we have to get the temperature within 1,000th of a degree.
What is this slight variation in temperature going to do to the line? I don't understand.
Thermals.
They're saying it's going to push the line up, so that way if the dip's not there in the middle that they need, they can just blame it on the temperature difference.
Convection exists, Jeremy.
I believe you.
Good.
Okay. All right. That doesn't seem like it'd be a huge issue, but anyway, let's move on.
It is.
Okay. All right.
It isn't for short runs, but you're talking about a mile.
Right.
When you start adding minute forces, the contributions, Jesus, Brian, give it a rest already. When you start integrating and adding up the minute forces over the length of a mile, it becomes very significant.
Okay.
George, do you ever listen to yourself, dude? Do you ever listen to yourself talk, man? So you need to go back and listen to some of the things you say, dude.
No, that was
you're a clever guy, very intelligent engineer and all that, but God, he said some of the dumbest shit,
times the length of a mile is a big force.
Right. Okay, let's move on. We can kick that around, but let's go to arguing about some NASA stuff. Well, not NASA, ISRO. So Where's Wally? You guys are all familiar with Where's Wally? I'll post a link to his channel. He likes to make fun of me, which is fine. I appreciate the support, Wally. I enjoy your videos. So let's take a look at his latest video. I'm sharing. You'll see me sharing on the sharing account in the chat. So you should be able to click on that and hear the audio. And the audience should hear the audio. Once I hit play, if the audience can just give me a thumbs up so I can make sure that the audio is coming through for them, that would be awesome. I'm going to start playing this. I'm going to let it play for a couple minutes. We'll get a feel for where he's going. And I'll stop it periodically to see if anybody's got any thoughts about what Wally says here. I told them we would review this, so we'll see where this goes, okay? Here we go. You guys can hear it in Discord?
Yeah.
Great. And if somebody could give me a thumbs up.
Where's Wally here?
In YouTube,
well,
that
Brandon
they can hear
Toy
it.
and
I'd appreciate
his
it.
Mobigalars, they've been playing with satellites. Professor Phil sent them a video of an ISRO rocket deploying some satellites, and they've been having a real field day. They think they've caught us all red-handed cheating and being deceptive and all that sort of stuff. Actually, I think they've just misunderstood a few things. So I'm going to go dive into Brandon's videos, because he's made about 3 or 4 of them already. I'm sure he's not going to stop yet. And let's see just what he's gotten wrong.
When a rocket launches satellites into supposed orbit, are those satellites supposed to fall into the clouds? And if you look closely on the right-hand side, you'll see that they are falling directly into the clouds. Now let's slow that down a little and take a closer look. Here you see the coffin-shaped satellite go right behind the clouds. Now the one on the right appears to enter a clearing and go right behind the cloud. In this frame we see the light on the furthest right of the satellite just before it enters what appears to be a clearing between clouds and proceeds to disappear into the clouds. Watch closely.
Okay, Brandon, so you reckon it goes into the cloud and comes out of the cloud, but how can you tell that apart from, say, the satellite being exactly the same colour as the cloud? You can't, can you? And that's exactly what's happening in the other footage. The satellite is exactly the same shade as the cloud, and it's only a couple of pixels in size. It gets eaten up by the compression and spat out and disappears. This is So here we have excuse number 1, that the satellites are the same exact color of the clouds. That doesn't hold much weight for me, since until it appears to go beneath the clouds, the exact point when you would expect that it is indeed going beneath the clouds, we can see the satellite clearly. If it were the exact same color as the clouds, you would expect that it would disappear at points where it doesn't look like it's under the clouds or going in between and coming in and out of the clouds. So it's not consistent when this decides just to ignore the color of the satellite and think that it's the clouds. The sensor seems to choose only the points when it appears that it's under the cloud.
No, it doesn't.
It does.
It disappears when it comes into solid cloud color. You're ignoring the blinking that occurs when the cloud behind it is a solid uniform color, when it cannot possibly be going underneath.
Nope, I'm not ignoring anything.
You are. You're ignoring that fact. These things blink. You're just looking at the points where they blink, where it's, the cloud breaks up. But what you are ignoring is where it's blinking, where it's over solid cloud.
No, I'm not. I'm not ignoring that at all.
Well, if you do, okay, if you're not ignoring that invalidates your idea.
It doesn't disappear when it's over solid cloud.
It does.
It doesn't.
It does. It does.
What
Some of the blinks that occur where it disappears are where it's got solid cloud behind it.
Right. They're not lights, dude.
Not lights. What?
He said they fade out of compression, or they pop out of compression.
Yeah,
what kind of shit is that?
Because when things get down to the size of a pixel, the compression algorithm will be flipping around, deciding what it can compress and cannot. And you could see the fact that it's blinking. Sometimes it shows a dark spot. Sometimes it's clearly either the sensor, because we're dealing with pixels here, just down to 1 pixel. The sensor depends on which part of the sensor pixel it is, whether it's going to show it, and then the video compression is going to then do that as well.
They're ejected the same direction that the satellite is going, or the rocket's going. They're ejected the same direction. Why are they dropping down so damn fast?
They're launched in the opposite direction to the direction of travel of the IS or the launch vehicle. So that's why they descend.
No,
if they have less
actually, they appear to be dropped
vehicle,
down. To be honest with you, they're like ejected downwards.
No, they're not. They're ejected backwards.
Well, that's what you say.
Well, you look at them. The video there shows it.
What are you talking about?
And that's the way it has to work as well, because to do the effect as I described the other day, you have to reduce the velocity, the orbital velocity, by such and such amount. I can't remember if there is a piece of video part of this footage
Show
where
the ejection
see
part.
them
It looks like it's going the same direction, man. They're
Yeah, no,
falling
but
down
still,
the same direction.
it's only 10 to 15 miles. As I remember, with looking at the image it being sprung out, I think Professor Phil Bell said they use springs actually to launch these things. So they're only going, and if you look at the video, you can see they go out by what looks like about 10 miles an hour to me. So that means they will very slowly descend as the result of them having
It
a
looks like
velocity.
they're dropped straight out.
Yeah, it does.
Excuse me.
That's what it looks
Excuse
like.
me.
What?
Does anybody? I'd like this question answered. Does anybody know how high up those the rocket is when they're launching the satellite?
It's about 8.5 miles, man. That might be 10 miles. I'll be generous.
576 kilometers, I think, isn't it?
That's what they say. Yeah.
Yeah, 576 kilometers, George.
576 kilometers.
Yeah.
According to IRS.
Okay, so that's roughly 300. Wait, just a minute. That's roughly 360 miles.
356 miles, I think.
360 miles.
Something like that, yeah.
Okay. Now, in order for the satellites to descend towards the Earth, it has to have a normal component of velocity towards the Earth. All right. How long do you think it's going to take the satellites to reach the clouds from that height?
George, do you think the clouds look bigger from 360 miles than they do from standing on the ground?
They're disputing the height.
To what?
You think the clouds look bigger?
Wait, will you shut up, Brian? I'm trying to listen to Rumpus.
This is not you.
No, forget. Just a minute, Rumpus. Just a minute.
We're disputing the height. Rumpus is correct. We're disputing that it is high as they say that it is, since we see them go into the clouds, and clouds are not that high. That's what is being disputed.
Yeah, I mean, at most, the clouds are going to be no more than 20 miles tops. So even at 100 miles, say you're 100 miles above the clouds.
This thing's not at 100 miles above the clouds.
Just a minute. Just a minute. Suppose you shoot
just above the clouds.
Rumpus.
The clouds look bigger from that than they do from the ground.
Can I jump in
Even
real
if you
quick,
shot
guys?
them
The
out
thing
towards
is,
the Earth, Jesus. Why is it so hard to talk in this show?
Go ahead, George. Go ahead.
What's wrong with you people?
To that camera than they are when you're standing on the ground, for God's sake.
George, they just think they're just above the clouds. I know it's insane, and you can see from the shape
It's
of the
not
cloud.
insane. That's clearly what it looks like.
Absolutely insane.
No, it's not.
Okay,
It's
let
not.
me explain
What do
something.
the clouds look like when you're standing on the ground, Rumpus? What do the clouds look like when you're standing on the ground?
Imagine how big that cloud is. Look, imagine how big that cloud is that we can see there. Clouds of that sort of shape are hundreds of miles across, or
for fuck's
tens of miles
sake,
across.
please
So
give me
it
a
cannot
fucking
have-
break.
so
As
you
if you're an
cannot
expert
have
on
gone-
fucking clouds
I
from
am an
different
expert on clouds,
altitudes.
yes.
Give me a fucking break.
I am an
Don't
expert
blow
on
fucking
clouds.
sunshine up our asses.
So
Jeremy,
therefore
go
we
ahead.
know
What did you
that
have to
you're
say?
just-
All of
I
you-
heard your bullshit, Rumpus. Just chill the fuck out for a minute. Go ahead, Jeremy.
Okay.
All of you guys
That
are idiots
side of the rock-
unless you know what the heights
Well, you're
are.
an idiot with us,
Unless
so
you know what the
shut
heights
up.
are, there's
Go
no
ahead.
point talking about
They're
this.
disputing
Okay.
it, George.
Hold on, Rumpus. Listen.
I'm saying, unless they
clouds-
know what the height is, there's no point talking about it.
Okay, great.
My God.
Fantastic.
All right.
Then be quiet. Go ahead, Jeremy.
Okay, obviously with the cloud definition we see in the Indian view, they'd have to be seriously zoomed in. Would you agree? Or you think you get cloud definition like that without being zoomed in from 480 kilometers?
I mean, I don't know quite. I'm torn.
Rumpus, do we get cloud definition like that at 480 kilometers without being zoomed in?
I would have to go and look. Look, if you saw the video hold on. If you saw the video later on, Where's Wally shows you from the ISS lots of cloud formations and the various shapes they have. So it's difficult to know exactly what the focal length is from the shape of the clouds, but they certainly. If you think that those things got to that cloud when that cloud would then have to be just a few tens of meters across, it's clearly not a few tens of meters across. Therefore, it cannot have got down to the cloud.
Fantastic. Let's keep playing. Let's go on. All right.
So just
here, let me show you. I'll zoom in on the satellite. I'll use the color picker to pick the color of the satellite from one of those 4 pixels. And now let me write the alphabet here using exactly that same color. Can you see that H is almost disappeared? You almost can't see it. That's because it's exactly the same color. What do you think the compression algorithm is going to do with 2 pixels that almost exactly match the color of the background cloud? Do you think it might just remove them, just to save space? I think you find it's going to do exactly that, Brandon. So it's not going into the clouds, it's being removed by the compression algorithm.
So you hear what he's saying here. He's just stating, yeah, no, it looks exactly like that. It looks like it goes to the clouds. But no, it's the compression algorithm.
And he's right.
Yeah, excuse number 1. Let's keep going.
It's valid.
How do you guys keep missing these
That was
things?
number 2.
I'm not backing down on that at all.
Okay.
This is sharpened and enhanced to show the detail, and you can make out the spots where the satellite appears to go in and out. Now, is that the same color, that black? Is that the same color as these clouds?
Yeah, but the fact that it's changing color and it went over a solid portion.
Is it the same color as these fucking clouds? Yes or no?
No, it's not the same color as those clouds. No, no one's claiming it is. Neither is he.
In
It also looks like it's disappearing and reappearing.
Exactly, when it's above the cloud.
Like it's materializing and
going
dematerializing.
in and out of the clouds. See how these are at
no,
different
that's not how
heights?
things-
You're seeing holes in the clouds. You're seeing clouds higher in areas and lower in other areas. It's going like this across the top of these clouds. It's very simple.
Why is there no reaction from the cloud
what's
then?
going on?
Yeah, it blinks.
Why is there no reaction from the cloud?
Yeah, because you're claiming that cloud and the object are about the same size, or that's about 1/10 the size of the cloud you're now claiming, which is ridiculous.
There would be some sort of eddies from this thing going through the clouds. You ever seen airplanes go through clouds?
Give me a fucking break. This thing,
I'm
do you know how big
totally
this thing
serious on
is?
this.
You think you're going to see the eddy that this makes in the clouds from that distance?
If you're zoomed in, if you're that close to the clouds, it's disappearing within 10 seconds.
That's nonsense.
Now we're talking about
something in the sky with smoke.
Brandon,
Now we're talking
of similar size. You're claiming they're on top of them, and the cloud is of a similar size to the satellite.
Now we're talking about
I
if
think
you're
you're
zoomed
claiming
in. You can see a piece of that.
Do you understand what Brandon's claiming here? He's claiming those clouds that we're looking at. So let's say it's about 10 times as long, 10 times as high as the satellite. It clearly is not. For it to go underneath it, it would have to be that size. That would have to be the size of a cloud, that satellite.
No, what the fuck are you talking about?
Right, okay, listen to
What's the size of a cloud?
Right. If it's
What's
gone
the size
down
of a
to the
cloud,
level of the
Ronda?
cloud, that means that it's at the same level of the clouds, the same distance from us. Therefore, that satellite is a 1/10 horizontally in the x-coordinate as the cloud. Absolutely
no,
ridiculous.
that is so ridiculous.
You just said it went into the cloud, which means the same level as the cloud, which means the same distance as the cloud, which means the sizes are comparable.
Do you understand how clouds work? Do you understand that this is not the same altitude as this? This might be a dip or break in the clouds. This isn't the same altitude as this. This isn't the same altitude as this. It's a cloud. It's got a bumpy surface, and this satellite is going like this and skimming through the clouds. Do you understand that?
You're claiming, and do you understand?
You're making a story up about what's happening.
No, I'm not.
I'm interpreting what I'm actually
just showing
watching.
you the implications of what you're saying. You're saying those things are the same distance. Therefore, that cloud is only 10 times bigger than the satellite.
Oh, that doesn't even make any sense. I'm not.
Right,
I'm not claiming that they're the comparison of the size. We can see how big the satellite is. Are you gonna talk over me this whole fucking show?
You're not letting me make an explanation out, are you?
No, I'm not, because it's.
Yes,
I heard you. I heard you. You will talk forever. Now listen to me. Listen. I'm not claiming that this satellite is as big as these clouds. That's preposterous. All I'm doing is interpreting what I'm seeing on the screen. We can see that the satellite is much smaller than the clouds.
Right. But you are saying that they're the same distance away, which means that cloud that woman is over there particularly is about 10 times wider than the satellite.
And?
That's the implication. Right. So you're now saying we've got a cloud that's 10 times size bigger than those satellites, which is ridiculous. We could see from those earlier images that those were big clouds.
No, you couldn't. No, you couldn't. You couldn't tell from
yes,
that.
You can.
No, you can't.
They're certainly not just 10 yards.
I get where you're coming from. Let's move on.
Brandon.
I get where you're coming from. It's ridiculous. Let's move on.
You're ridiculous.
Digital artifacts.
It's so obvious a child will understand what I said.
Oh, Brandon, you can't just keep enhancing. You're not CSI, Brandon, are you?
No, I'm sure
mate,
George
every
agree
time
with
you
me.
enhance or zoom, you're
you and George
changing
versus
I'm playing the video.
sometimes adding information
that?
to it that's not there. Now, you know this. If you take a regular size image, shrink it right down, and then expand it back up again, you're going to not see what you started with, are you?
Here's this next excuse, which is to somehow imply that I don't know how to use the functions in the video player that I'm using or editor that I'm using. I don't know what his point is here. All I did was sharpen the video, use the sharpen tool, that's what it's called, so that we could maybe see a little bit more detail. That's it. I don't see the problem with that.
That's what you were trying to do.
Well, it introduces extra shapes that aren't there in the original, that's all.
I'm not backing down on that at all.
No question.
It's striking how much detail there is in the 576 kilometer ISRO footage on the right, and how little detail there is in the Mage 2 38,000 meter footage on the left.
Where were they when they released
Especially seeing that the one on the right is supposedly almost, actually more than an order of magnitude higher than the one on the left. I don't know what it could account for this. Maybe there is a difference in the weather between these 2 days or locations, but it sure is a striking difference.
Well, okay, Brandon, you guys think you're cloud experts. Here we go. Here's a little quiz. Tell me which clouds were taken from the highest elevation. Is it clouds A, clouds B, cloud C, clouds D, well, maybe it's all of them, because yes, they were all taken from the ISS from the downward pointing live streaming camera. And that scene is about 100 kilometers.
You know what I found funny about this? He's showing all these different clouds from the ISS. They all look like they are much further away than the clouds in the ISRO footage looks.
Exactly. I've studied high altitude balloon footage, and every picture he just showed, high altitude balloon footage get higher than that. It's visually easily seen with your eyes without any tools. You could easily see that 100,000 feet is higher than them damn pictures, or close to it at best.
That's just willful misinterpretation. Also, the camera's not the same. This is a different focal length on this camera than the one that was on the Indian.
I'm sure it is. I'm sure it is, and it really doesn't matter since the one on the ISRO was a wide-angle camera. So,
how much could it have been zoomed in if we can see the piece of the rocket on the right?
Exactly, that's the point. You can see the piece of the ejector that's pushing the satellites out, and that's in focus. So the ISRO footage is not zoomed in.
The trouble is, it's so poor. The image's resolution is so poor. It's very difficult to work out what is and is not in focus.
The point is viewers zooming when they're first releasing them would fill the whole damn screen. So they really messed up, because that would have been y'all's #1 claim. It always is, but he can't use it on this because he accidentally caught the satellites coming out, or he did it on purpose and didn't think about it. But they would fill the whole screen once you zoomed in past 100 millimeters. They would fill the whole screen.
Right, but these images of the clouds demonstrate how big clouds are, and for Brandon to claim that those satellites disappeared into a cloud that was only 10 meters across, and the other clouds in there only 10 meters across, is ridiculous.
And why is that ridiculous? No, never mind. I don't want to know. I don't want to know.
Anybody who denies that is not honest.
So, yeah, so that's his excuse. Let's just skip to the next one here and see what he's got. He made this into chapters. We're not going to watch this whole thing, but
see the diagram. Okay,
all right,
here's
here
the
he's talking
ISS,
about
and
the
you're
vector that
outside
these
in
are
your spacesuit,
launched.
and you've got an
I don't
object,
know about
and you
you,
want
but
to get rid of
clearly
it,
in the
and you're going
footage,
to
it looks to
jettison
me
it.
as if
Let it go
the
back down to the ground.
satellites are
Which
going
way
towards the
are you
ground.
going to toss it? A,
Yes, but they were launched
B,
backwards.
or C?
Right.
A, forward,
That's why they're falling towards the ground.
B,
I got
down.
Yes, exactly. The maths says that's what will happen. Just
Okay,
because
then
you're
he,
ignorant
then
of
he
that,
shows
it's your
this
fault.
stuff. I
That's what
want
happens
to
when-
watch one more part here.
That's what happens when you go slower in orbit. You drop below it.
Exactly.
Okay, this is pretty amusing. Phil
I
shows
love
up.
Professor Phil. Thanks, mate.
Here he goes.
Because in order to
Well,
go down, you have to
hello,
go
Brendan.
slower.
And a big friendly
Yeah,
hello.
we heard all that. We heard that whole story before. So let's watch Phil.
It's not a
well,
story,
no,
Brandon. It's
flat
the
Earth
orbital
stories.
mechanics.
Yeah,
Yeah,
just
I
basic
understand
physics
it's
and
your
orbital
mathematical
mechanics.
model. I got it. Can we watch this? Let's listen to Phil.
Go ahead.
And a huge shout out to Wes Wally, who's deconstructed the footage perfectly for you, as he usually does. And of course makes you all look silly while the rest of us are enjoying some side-splitting laughter. So, Brandon, did you miss the RISAT satellite launched from the very same payload, where you can see that the Earth is spherical?
This amused me very much because I don't know if you'll remember back a couple of months ago when we originally looked at this footage and at this RISAT satellite, this gold foil thing. We were very amused by this. This thing looks absolutely ridiculous, as does this piece of Earth here. He's using another piece of this footage to try to substantiate the part where the satellites are falling into the clouds.
Yeah, and this is
You
clearly
said
taken with a different focal
he did.
length.
I notice how you carefully ignored it. So, Brendan, you said you don't know what those objects are that you can see moving in the night sky 6 times faster than a fighter jet. Well, here's a question for the next show. How come I can predict exactly where a new one will appear in the sky and no flurf can do it? Do I have a special direct line to God? Well, anyway, Brandon, a giant thank you to you and your flurf peers for the awesome entertainment that you always provide. It's just a few orders of magnitude funnier than a bunch of cats chasing a red laser dot on the wall, but pretty much the same genre. We just love watching you all freak out in a frenzy when we send you stuff like this. And I'll send you another one. Much more remarkable, actually, shortly. Now, Brandon.
Nice try, Phil. Playing it off as if this was all part of your plan, bro. Nice try.
Just because he can predict where a satellite's going to be means nothing. I can look at a clock and predict where the hour hand's going to land. So what?
You can predict where satellites will
What is
be.
it?
I mean, what does that have to do with these images of the satellites falling into the clouds? Anyway.
Well, one, he's demonstrating how high it is in comparison to the clouds, so we know we're well above the clouds.
No, he's not.
And two, yes, he is, because you can see the curvature of the Earth, and you can, in that earlier footage, you can see. I presume that the focal length on that is slightly less than one on the clouds. So
That's not Earth
why.
curve. We would expect to see a curved horizon on a flat Earth. That's flat Earth.
Yeah, but not
flat
from
Earth
this
curve.
height. You wouldn't. Not from this height.
Yeah.
You wouldn't.
That was obviously a
No, you
fisheye
wouldn't.
lens
That's
anyway.
flat Earth.
We're not concerned about how they made the Earth look or what the camera that they used. It's
Oh, you're
highly
not concerned.
deceptive. So
Well, it just demonstrates that they are high up, because you wouldn't get that effect from being low down. So that demonstrates we're a long way away from those clouds. And as I pointed out, just doing some image analysis means that you're claiming that those clouds are about 10 meters across, which is ridiculous.
well, how is that ridiculous? There's clouds of all sizes. I don't understand why you keep saying this.
Okay, because we can see, if you see the other bits of that footage, you can see those clouds further up, and you can see them in context in comparison to the horizon, the shape of the Earth. So you can see they're huge, which invalidates your whole theory that they're going into them, because your theory requires the clouds to be very small. If they're going into those clouds, you require those clouds to be tiny, and you can show from the earlier footage that they're not.
Not tiny. Not as big as you're making
Yes,
them
you
out
are
to be.
10 meters across.
No.
You saying that those satellites went into the cloud.
It
There
was
we go. So we're
taken
getting, I don't know if that's from the
Chandrayaan
same,
2
I don't
on
know if
its
that's from the same image.
48-day journey
But
to the moon.
the point is, your claim is
2019.
based upon them reaching the position of the clouds in elevation altitude. And that would mean that those clouds would have to be just a few 10 times bigger than the satellites. They're clearly not. So we can invalidate and then invalidate your claim completely.
No, I think your math's messed up, but we'll move on.
My God, it's simple logic. And obviously,
So let's see if you can have some fun with it. Give Wally some more work to do. Cheers.
Oh, thanks so much, Professor Phil, for those kind
Here's his
words.
new
Much
footage.
appreciated. But Phil, I think you're more like the cat. You know, the cat that caught the mouse and he's toying with it. You know, I just love how they lay on the lawn there with the mouse and they roll the other way and let the mouse run away. The mouse thinks he's gotten away with it. And the cat is just waiting because he enjoys the pounce. He wants to pounce just one more time. And often the cat, he's not even hungry. He's just in.
I don't know, guys. We didn't watch the whole thing, but I will link the video. I don't know if anybody was convinced by that or has any thoughts on what Wally put out.
You know what he tried doing with the Earth when he said we saw the Earth curve there supposedly. Globers do this all the time. You pull a citation out, refuting what they say, and then they'll read the whole reference and say, "Oh, but look, 3 paragraphs later it says the Earth's a sphere. You lose."
Yeah,
they do that a lot.
That's called cherry picking.
You have to show how the cherry picking changes the meaning. Like they did that to me once when I showed in a perspective notebook that they appeared to be working what appeared to be off of planar mathematical models with no curvature factored in with like a parabolic curve or a circle or anything. And then they pointed out somewhere in the book where they said the sphere is so big it looks locally flat, which is a verbal justification, but not a mathematic one where it looks like they're working off of planar mathematical models that don't really adopt any form of curvature. So they may have called that cherry picking when they said in the perspective notebook that it's a sphere that looks so big it's flat, but mathematically they didn't treat that. So for all intents and purposes, if it is cherry picking, I don't know how it is because it hasn't qualitatively changed the meaning of what I said one bit. That perspective appears to be based off of flat mathematical planar models, as far as I can tell.
Well, maybe you didn't do one, but you're a hero QE. Cherry picks better than anybody, and he should work in the cherry industry up in Washington.
I think you talk about QE more than anybody else in this whole arena. Paid
because he's like the ultimate flat Earth show.
Well, I mean, I can't speak against my my fearless leader, my FE fearless leader. But if you can show how the meaning changes later on in the text, that's all you.
Hey, Lemonbird, I think I found that online correspondence course you're taking. How to speak bullshit fluently.
Oh, yes. It's about $45 a month. It's wonderful. Taught me everything I know, especially about the globe.
I thought that's one of the prerequisites. That class is one of the prerequisites before you can become a flat earthologist. Tell them, Lemon.
Yeah, I thought it'd be free, called public education. Right.
So true. But there is no hump of Earth curvature in the way. It's just 2 planes of vision, the top and bottom half of vision, merging into an unresolvable horizon line. That's it.
That's incorrect. You know it.
It is correct. You don't think there would be a horizon on a flat plane?
There would be no horizon on a flat plane. Or the horizon would be much further away, and you could see much further.
Well, how would you know that there would be no horizon?
How do you even know
that? We're talking math. Yeah, how do you know that? That's a good question, because there is no flat plane to compare it to, is there? We have to know what that math is.
You seem to know all about it. Tell us.
We have to know math. You guys don't know math, except for Lemonbird, perhaps. But the rest of you don't know enough math.
How would you know it? You just said, how would you know it? There's no flat plane to test it. But you just told us what it would look like on a flat plane, so you're just
because you can simulate a flat plane.
No,
it's called math. It's called math, man.
It's called making shit up.
No, it's called math, because you have to make shit up because the Earth isn't flat.
You went to MSU. making shit up.
I'm gonna do some math. Earth is sphere.
But the thing is, you said there'd be no
I'm sorry, I can't
horizon.
speak math.
Would it be all sky or all ground if there's no horizon?
There would be horizon, but it would be much further away.
Okay, so you admit that there would be at least half sky and half ground, right?
It depends on your angle, but yeah.
He doesn't know. He just said.
So what would happen to the objects sticking out of that plane? Wouldn't they be subject to angular resolution and diminish in size sticking out of that plane?
Would. So would the sun, and it doesn't set. So with the sun, it would get small and small and small and never go below the horizon, but that's another issue.
That depends on how close to the surface you are, though, doesn't it?
No, because the sun would never go below the horizon if it's above the horizon on a flat plane.
But if you're in a hallway with a really tall ceiling, eventually the tall ceiling, like the sun in the sky, will appear to dip down. If you're too close to the surface, it will dip down below the horizon that's made in the foreground due to angular resolution. There you go.
No, it will not go below the horizon on a flat plane.
It will appear to because of converged visual angle.
Math.
It will appear to because of converged visual angles.
Wrong.
Yes, that's what's going to happen.
No, it's not going to happen. It's going to the sun is not going to disappear when it's 30 arc minutes big. It's going to disappear when it's like outside your Rayleigh criteria, which is a hell of a lot smaller than 30 arc minutes. Do you agree with that?
Well, you have to compute the Rayleigh criteria correctly.
Is the Rayleigh criteria smaller than 30 arc minutes?
The Rayleigh criteria is 0.02, which works out to 1/50th of a degree. So that's what almost 2 or like 1 or 2 arc minutes, something like that. Somebody break out the calculator. It's 1/50th of a degree, and arc minutes like a 60th. So that's like 1 or 2 minutes of vision, roughly.
So about 15 times smaller than the sun when it sets, right?
Well, it's going to set early because you're too close to the limiting flat surface that's lowering the angles available to the bottom half of your vision.
No! You're coming up with some sort of bullshit angle of attack stuff again.
Yeah, because your eyes want symmetry. They want
they don't. Your eyes don't care about symmetry.
And the angles in the bottom half of your vision with that 6 foot from your eye level flat plane in the way.
Shit about symmetry.
Much more limited than they would be if you were levitating up in the air with a wider visual field.
Incorrect. All around.
The angles in the top part of your vision will be wide and ample, and the same angle in the top half of your vision will accommodate much more visual information than the compressed angles in the bottom half of your vision. But those angles are going to be paired.
Totally incorrect.
It will appear to set bottom first.
No, we'll never do that on a flat plane. You cannot.
Wrong, dude. Your
philosophy
of vision is a little
off.
Yeah,
you see it all the time because the Earth is round.
There's no curve to the horizon, though. Not without curving lenses. You ain't got it. I'm sorry.
Brandon, do we have any word from that woman with the idea there?
No, we're good. We can bullshit about whatever you guys want to talk about.
Oh, I wanted to hear from that. I wanted to hear from her.
Oh, yeah. No, I haven't heard from her. Maybe she had something else to do.
I told Babs. I told you I told Babs.
What's that?
I told you what I told Babs. Babs had an idea. I'm like, bro. He was like, oh, I'll pitch it tomorrow. And Jem's like, bro, you need to tell me right now in case you die tonight.
Oh, jeez. Hopefully she'll be around tomorrow.
Yeah.
Now, with this Rayleigh criteria, a nice ample 0.02 angular resolution angle of vision in the top part of your vision from your eye level up could encapsulate up to thousands of miles before it sets early. But on the bottom half of your vision, you reach 0.02 after like 3-6 miles.
Lemon, have you ever put your
but you're going to have much more information in the top half of your vision, 0.02 and above. Yeah. That's going to set early.
So if I stand on my head, is it backwards?
Let me say something. Lemon, have you ever?
Hey, Lemon, how is it that your vision or your eye encapsulates anything?
Lemon, have you ever put your eyeball down? Hold
Jeremy?
Oh, yes. Lemon, have you ever put your eyeball down to a chessboard and tried to look across it and see how the last square looks?
I have.
You can almost barely see it now. Nothing's blocking it. It's just your angle.
Yeah.
From the floor to the
And as we
making a
know,
cute
that
angle.
2D representation of those blocks is qualitatively no different to the eye than a 3D object with height, breadth, and depth equal to those squares on the chessboard. But what were you saying, George?
Also, I must say that the lights
I
don't
said
follow the red
you
criteria
use
same
the
as solid
phrase
objects
your
do.
eye encapsulates something. How is it that your eye encapsulates anything?
Well,
You look at an airplane, man. Hold on, look at an airplane and way up in the sky at night. Okay, it's so small. Look at the red light. It's like a quarter or a fourth the size of the airplane. So the light obviously doesn't follow the Rayleigh criteria the way the dull objects do.
And also, George, everything looking down the hallway appears to converge toward the level of the eyes, so that's where you got to start to make angles. As we know from perspective, parallel lines appear to converge, merge, and disappear. So stuff that's going parallel to that hallway that you're looking down, or parallel over the flat plane, will similarly converge more or less toward the level of the eyes.
Yeah, there's more effects happening optically than just refraction that you guys think. Oh, it's just refraction. No, there's way more shit than that you guys won't acknowledge or admit to.
What do you know about vision?
I know that you can have obstruction without something physically being in the way.
That's right.
Yeah, how?
And it's
have you ever put
basically
your eyeball down to a chessboard?
Yeah.
You missed the
probably
point.
you probably play checkers. Have you ever put your eyeball down to a checkerboard?
You missed the point, Lemon. Encapsulate is not the right word. Encapsulate means to surround something, to contain it. Your eye does not surround anything or encapsulate anything. Just use your English properly.
It sounds like a nice word, though.
You got to crowd the light into your eye's opening. All that light's got to crowd into your eye in a nice symmetrical way at the level of the eyes.
Wrong. No, wrong. Your eye sees stuff like a camera. It doesn't crowd in there. What are you talking
So
about?
how does the light get inside of the optic to be focused?
The pupil captures it, encapsulates it, capture.
Whatever the word is, forgive my crummy English or whatever. This light has to crowd into the eye at the level of the eyes around there.
It doesn't crowd, it just...
Well, how should we excuse the improper use of language? The whole idea of language is to communicate. And if you can't use your language properly, then you can't communicate effectively. That's why we perceive everything coming out of your mouth as being bullshit, because you never use words
like straight
correctly.
and like straight and curved, like open and closed. Look who's talking, man.
Yeah,
That's
seriously,
why
you guys
go
are
back
the
and
biggest.
listen to yourself, bro.
Well, we could use some better terms, and that's why iron sharpens iron, and we can talk to each other globe and flat. 500 years later, maybe we'll have a better synthesis, maybe.
George, you know that you can have obstruction without anything tangible in the way, right?
How?
No physical. Have you ever put your eye down to a chessboard?
How is it in the way?
Have you ever put your eyeball?
How is it obstructed?
Have you ever?
Ed, shut up.
If nothing's in the way, then nothing's being obstructed. Again, it's the improper use of the word obstruction.
You can't see the last square on the
No, you
chessboard.
can- you
Is
can't
there
make
anything
it out.
obstructing it?
You can't make it out. You can still see
Yeah.
it.
No, you can't see it. You can't make it out anymore.
No, you can make it out. You can't make it out.
Barely.
Still
Barely. If you had a longer chessboard,
But
you wouldn't be able to make it out at all.
So it's not obstructed.
No, you can't. You won't be able to see it the
But
longer
it's
the
not
chessboard is.
obstructed, Jeremy.
It's not obstructed, but you can't
Right. So it's not
see it.
obstructed.
Right. So we know things can disappear without
Right.
anything getting in the way.
So say it's proper.
Well, what's happening?
Obstructed.
Well, what's happening with the coin that is not obstructed, but has disappeared above the surface? It's gone beyond angular resolution, right?
You just can't make it out anymore. Doesn't mean you don't.
Okay. And so you can't make out these visual zones anymore that have appeared to dip down toward the level of the eyes.
What's the difference between not being able to make out something and not seeing something?
No difference at all. You're being silent because you're trying to find a way to say you're right without saying you're right. There's no difference at all.
But I am right, and you're not.
Well, I know you're a proud man. You won't admit it. It's fine.
Here's the difference.
Give us a layman's
to finish. If you're looking at a
Hold
wind
on,
turbine,
hold on. You was interrupting. Just give me a layman's definition of the difference between the two, because
I'm
you
going
seem
to give you
to
a
be
visual
using
difference. If
as
you're looking at,
is there
can I
something different?
finish? If you're looking at a wind turbine that's say 100 meters high, and you're only seeing the top of it, the fact that the angular size is utterly irrelevant because it's big enough to be seen. It's therefore the fact that it's missing is because it's obscured. The example.
What
that
about
Jeremy
the angle?
Hold on, let me just finish. The example Jeremy gave is absolutely irrelevant because the point is the angular size of the thing you're trying to see, the distant checkerboard on its side, is incredibly small. That's absolutely irrelevant to things we see like mountains or wind turbines. We can clearly see the tops of a wind turbine that's 100 meters high. We can't see the bottom, and it's missing because it's being obscured.
No, it's
not
because of the
it's too
angle.
small.
It's
No.
because of the angle
No.
of your
No.
eyeball down to the
No.
dashboard.
The angle to the top of a wind turbine is exactly the same angle as to the bottom. Same with a mountain. The angle is
Not
no
the same. You're saying the
It's
angle is the
idiot.
same to the top?
It's
Hold
the same
on.
angle, but your eyes.
It's not the
interpret
same
it
angle. It's not the same angle.
It is the
from
same
top to
angle.
the bottom.
It is too, Jeremy. It is physically. It is. You're right, but your eyes will interpret it different. So you guys are talking two different things, and you guys are just passing by each other.
Try it again.
You make an angle. Stop. If you make
at a
an
wind-
angle to the bottom of the turbine, and then you make another angle from your eyeball to the top of the turbine, you think that's going to be the same angle?
They've got
Yeah,
the
you
same
don't think it's coincidence?
It
You don't
is?
think it's coincidence that the
It
flat
is.
Earth horizon and the globe Earth
That's
horizon match
fucking-
up so closely?
It is, Jeremy.
Look, let me
What?
show
It's
you,
fucking
Jeremy.
stupid. What you
No,
guys are saying
you're
is
a
being the
moron.
same angle is
No,
stupid.
Here we go.
I'm
let
going
me
to draw a line, a straight line from my
Go
eyeball
ahead, draw,
to the
draw it.
bottom of the turbine,
draw it.
and then
Then draw
another
it,
line. Shut
Jeremy.
up. I'm
Draw
going to make
it.
an angle. I'm going to make an angle.
Right.
Straight line.
Show
Shut
it.
up. Make an angle from my eyeball to the bottom of the turbine, and then another straight line from my angle from my
Let's
eyeball.
see it.
Shut up. You know what? Forget it.
Right, here you go,
Fucking-
Jeremy.
No,
That's
Ed's
just
a
stupid.
rude
I hear
bastard,
what
man.
Jeremy
Ed's
is
saying the same
stupid.
thing.
Jeremy,
How
can
can
you
you
see
It's not
draw
the same angle.
perspective, you dingbat?
Jeremy, can
It's
you
not
see
the
my
same
picture?
angle.
It is.
It's not the same angle.
Jeremy,
As you
can
get
see my
further
picture?
away, it becomes the same
Ruckus
angle.
goes on a
It's
huge
objective, it's not the
lecture.
same angle.
Can you see my
What
picture?
Jeremy is saying makes sense. You would have two different
No, it
quantum
doesn't make sense at
angles
all.
from the eye level down to the bottom of the object, and then from the eye level up to the top of the object, you would have a different angle, and you know it.
As you get further away, the angle
Hey
becomes
guys,
the
no one can
same.
hear.
Can you see this?
By
Jeremy, can you
making
see
a
this?
perfectly valid
Jeremy,
point
can you see this
Lemon,
that
picture?
stop
Hold
you
on,
don't want
Ruckus.
to
Hold on.
accept.
Right, Jeremy, can you see this picture?
Oh, you're drawing stuff? Hold on.
This is a photograph
Oh boy.
of some wind turbines in the distance.
Okay, draw a line from your eyeball to
Well, hold
the
on.
top of the wind turbine.
Okay, right. The point is the angular size. So the bit that's missing, and I've actually got the actual wind. Oh damn it! I've got the size of the wind turbine. So another image.
Draw a line from the.
You do it, Jeremy.
Okay, let's go. Here we go. What do you want me to do?
Draw a line from the center point of the screen to the top of the wind turbine.
Well, okay. I'll pick on.
Use the ground is one line of that angle.
I'll go and pick on. I've got another picture which actually overlays the image.
Do an orthographic view. Your Muppet vision. You love that.
No,
Do your
this is
Muppet vision view.
This
And
is
use the ground as
I'm
one
gonna deal
line in that angle.
I'm going to deal with photographs. Let me just go and check. Sorry, I'm going to have to go and find the other image I've got that I can never find.
It's not rocket science, okay?
It's obviously a different angle.
Listen,
No.
one line of
it's
that
not,
angle is
Jeremy.
always the ground. One,
Holy
Ed,
You
Ed,
keep
one
saying
line
it,
of
but
that.
you're not showing it. So
Why do you
show
keep
it.
saying it's not rocket science when you don't understand rocket science either?
Because Ed, I'm trying to tell Ed that the ground is always one line of that angle. The angle
Well,
is
maybe
measured
if
at
you
the
would
eyeball.
stop
Listen,
shouting in your mic,
if
I
you
could
wanna hear what
actually
I have to say,
understand what you're
listen,
saying.
the line, the
Because
angle
right now
is
it sounds
written-
like you're talking
Oh
to
my
me
God.
from the moon.
Ed, stop. Ed, stop.
Yeah,
The
take
angle is
take out your
drawn
mouth and
at
talk
the
at a
eye.
normal volume.
The angle is drawn at the eyeball, okay?
Here we go.
One line of that angle is the ground, okay? And whatever height above the ground is the other line of that angle to the eye. The angle is drawn at the eye.
Right,
Understand?
Jeremy, can you see this picture? Sorry, Brian, I didn't mean to interrupt you.
You're
So,
good.
Jeremy, can you see this picture? Can you see that the hub on this particular one, I've overlaid the shape of the wind turbines, and the
Ruckus.
angular size of from the hub to the water is the same angular size from the water to where
Draw-
the base is.
Draw a line.
The turbines, how big they are in the back. They're magnified.
Rumpus.
There's
Draw
no
a line.
magnification going on.
Draw a line from the top, from the center of the frame.
What's that got to
Straight
do with
out to
anything?
the top.
The center of the frame is something that's absolutely irrelevant. I could be looking up or down or tilt the camera. It makes no difference to the angular size of it. There's something the flat earthers don't
Draw
understand.
We're not
I've
talking about angular size.
got to make
We're
this
not
point,
talking
Jeremy.
about angular
Hold
size.
on. No,
We're
Jeremy,
talking about the angle.
Jeremy, I've got to make this point, and this is something that Lemon Bird fundamentally doesn't understand. The center of the frame is irrelevant. I could tilt my camera up or down, and it would not change what I see. It just changes where the center of the frame is. So the fact that you mentioned the center of the frame means you don't understand the basics of photography.
You arbitrarily picked one that was equal. Pick the one over to the left. Jeremy, this is why you have to catch Rumpus's photo directly, because Rumpus is tricky. Rumpus, draw the angles down from the one to the far left. Different angles from the top to the bottom, and you know it.
Shut this guy up. I'm trying to make a point.
Rumpus will just lecture you to death. So you just
wait, there's 3 of you guys talking at the same time right now. I have no idea who was talking first, but everybody shut up,
being
please.
dishonest when you're doing it. You're picking one that's equal arbitrarily.
Can you guys hear me? Because I'll give you each a chance to talk, but
can I make my point?
the audience cannot hear. Make it quick, Rumpus.
Right, Will. Right. So the point is the angular size of the hub point of the wind turbine and down to the base is exactly the same. So the angular size of these two things is the same. So this idea of Rayleigh criterion or anything is utterly irrelevant. This is clearly big enough to be seen. Therefore, the Rayleigh criterion and all that crap is utterly irrelevant. And so the only thing
arbitrarily picked one that was
for the fact that we're missing half the wind turbine is the fact that it's obscured.
You've already made that point, Rumpus, and you pick one that was arbitrarily equal. Your ratios are totally different for the one on the far left.
It's just because Jeremy wanted to.
So let Lemon respond now. Lemon, go ahead and respond now. Rumpus, shut up while he responds, please.
Anyway, Rumpus, you have different triangles from the eye level up versus the eye level down, and you know it. When there is too much compression at the level of the eyes past the angular resolution limit, that is interpreted as obstruction. And you can see that with the turbine to the far left. If you do the ratios on that one, they're totally different than the one that's equal in the middle that you chose.
Brandon, check your DMs real quick. I sent you a picture of how the angle is different from the top of your eyeball.
So what's the point? Sorry, Jeremy, can you repeat that? I didn't hear that, Jeremy. Can you say that again?
You guys are telling me that the angle's the same from my eyeball to the top of the.
Well, in this particular, I've chosen an example. Right, I've chosen an example where that is the case for the hub. But it's
actually never the case. It's never the case.
It is. Look, you idiot. The angle from the top that you can see down to the bit that's obscured is the same size. The angular size from the hub down to the
let's hear what Jeremy has to explain about the drawing that he put in there. Jeremy, I'm showing it on screen right now.
Yes, just like the chessboard or the checkerboard, the angle from your eye is different to the ground of the base of the turbine.
No,
to the top of the turbine. Look at the lines. Does that look like the same angle to you, Dip?
Well, you just drew something. You didn't show anything.
This is so dishonest. It's taller from.
No, it's not dishonest.
Is it taller from your eye level up or from your eye level down? The moment you honestly say that it's taller from your eye level up, you're going to have a different triangle and you know it. You guys are being a little dishonest.
No,
you're consider the ground as half of the angle. Look, if you consider the ground as half the angle, it doesn't matter what direction you turn the fucking lens. The ground is still the bottom of your angle that you're drawing.
Jeremy,
the lower you get to the ground, the tighter the angle is.
Jeremy,
in my drawing, everyone who said it wasn't the same angle, who said it was the same angle, is an idiot.
No,
look at my drawing.
You don't
understand. Dishonest and using weird parlor tricks to do so. That's why I got to catch Rumpus and these other dishonest parlor tricksters.
You could have that floating in midair and it wouldn't make any difference to the argument. You're obsessed with the fact that you're at some eye level.
But you can't disclude the ground, bro. I agree that up in the air, angular resolution. No, you can't. The ground is part of your angular resolution.
If the sea in my photograph was glass and transparent, you would be able to see the rest of the wind turbine.
No shit.
But it's not.
If the sea was totally transparent, you would be able to see the missing part of the wind turbine. The sea
Dude, that
is
is so
obscuring it.
stupid, dude.
Okay, are we all on the
Are
same
you
page?
kidding me?
Hold on. Are we all on the same
If
page?
the sea was transparent, it'd be up in the air.
Are we all on the same page that from your eyeball to the top of the wind turbine and your eyeball to the bottom of the wind turbine is a different angle? Are you guys ready to concede?
No, we were talking about
Are you
angular
guys
size.
ready to concede that point?
We were
yet or
talking
no?
about angular size. Look, you just don't understand what angular size is, do you? You're really stupid.
That's why you can't answer honestly. That's why I just rumpus all over you, because you're not going to be honest. And even answer Jeremy's question with all of the implications therein, so you get rumpus and you get told the truth.
Making it up as you go.
Obfuscation.
But you're just making it up, Lemon.
All right, so we got a super chat. Here, let me break in real quick, guys. Let me break in, please. So we got a super chat that came in from C4. What's up, C4? Thank you. Rumpus, can you please call Jeremy a utter, and you can fill in the blank.
Right.
That wasn't enough utters.
Jeremy, actually, although I disagree with him, he seems like a reasonable guy to me, unlike Lemon Bird. So I'm reluctant to abuse him in the same way that someone that's obnoxious like QE. But he is being a bit of an idiot at the moment. I'm going to show him why he doesn't understand what angular size is.
Rumpus.
I think
I'm not talking about angular size. I'm talking about the angle from your eyeball
But that's
to the
Jeremy,
top of the
that's
wind
what
turbine.
matters. The Rayleigh criterion and all that crap you're talking about is the angular size. It doesn't matter where it is
I
at
think
absolute
Rumpus,
term.
Jeremy's talking about inclination angle from your eye level to the top of the tower and from your eye level
let me ask
to the
Rumpus a
bottom of the
question.
tower. That would be an inclination angle, not
Let me
an
ask you a question,
angular
Rumpus.
size. He's not talking
Y'all
about
give
the
me one
angular
question,
size
y'all.
angle.
Okay.
Give me one question. Okay, Rumpus, pretend something is like so far away that something 100 feet looks like it's like a eighth of the size. Okay, so it shrunk down to that
What does that even
angle,
mean?
right? Now,
What does that mean?
Picture this. Listen, you got to make the ground part of the angle of your angular size. So in other words, if something
No, you don't.
What does it mean to say it's 100 feet and now it's 12 feet? What does that mean?
Tall, in other words, listen. The point is the ground is one part of your angle. Okay, so if something's above you, then the ground is no longer a limiting factor. You've got to consider the ground as part of the limiting factor in your angle. If
What
you're
does
not,
it
you're not
mean
being
to
honest.
say something that is 100 feet tall looks 12 feet tall? What does that mean?
That's why I changed it to just saying that if you got to use the ground. Show it, Jeremy. Make a drawing with a flat ground.
Well, I'm showing a
It
diagram.
doesn't matter what the ground. Yeah, I just freehanded it. I didn't have a ruler or anything.
I've got a new diagram you might be interested in, Jeremy, about showing you what angular size is.
No, hold on. Are you ready to concede that your angle from the top, from your eyeball to the top of the
Irrelevant. We're talking about angular size.
Christ.
It's irrelevant, Jeremy.
Yeah, it's irrelevant.
It's not irrelevant.
It's
Completely irrelevant.
Jeremy, you're claiming that the angular
Rumpus,
size.
I didn't hear Jeremy finish. I didn't hear him finish.
Okay. Well, I was just going to quickly say to Jeremy, the angular size of the thing you were claiming got so small it disappeared. It's the angular size that's important, not the absolute angle. Go ahead.
Okay, when you put your eyeball down to the chessboard and you can barely see the last square.
Yeah.
Because of the angle. When you raise up, you can see it.
No, it's to do with the angular size of the object you're looking at. Well, that's what's caused it.
Yeah, and we're looking at things. We're looking at things
how does the angular
perpendicular
size
to our
change?
line
I
of
got
sight,
close
not
to
parallel to it.
I got closer to the square by putting my eyeball down on it.
Look.
Yeah,
it's all about the angle.
famous example.
It's all about the
tracks
angle.
No, it's not. Look,
Guys,
Jeremy, Jeremy, look at this diagram.
Just go ahead. No, I'm done with you guys. I can't get
Jeremy, look at this
out.
diagram. Okay, please look at this before you go. Look at this
No,
diagram.
my bad. Let Jeremy make his point real quick, Rumpus, then respond, please.
Okay. I've got a diagram for Jeremy here. Specifically, I spent ages trying to find.
Okay. Just like the chessboard, we didn't change the if anything, we got closer by putting our eyeball down to the checkerboard. We got closer to the last square. We didn't get farther away. The reason we can't see it is because of the angle. Now your
but
angle
we're not
from the
looking
eyeball.
at things. We're not looking at things that are parallel to our line of sight. We're looking at things that are perpendicular to our line of sight, like mountains and wind turbines and buildings.
Picture railroad ties. Picture cross ties on railroads. You're still above them, bro, so you can't say they're being blocked, but you can only see about 10 or 15 of them. but you're still above them.
Angular size.
Right, Jeremy, could you please look at my diagram here I've got for you, showing you what angular size is all about? And I'm showing you the
I know what angular size is about.
Well, good.
Rumpus, you don't need to tell me about angular size.
Right, but don't you understand by
I'm not
going
talking
down?
about
Hold
angular
on, Jeremy.
size. I'm
Don't
talking
you
about the
understand
angle.
that by
I'm talking about the angle.
Jeremy, but you've changed the angular size of it because you're looking at edge on, as Ruhif said. You've changed the angular size because you're looking at a different angle. Whereas what you need to consider is the fact that those wind turbines were perpendicular to you. So the way you orientate your eye, if you move yourself up and down, it doesn't change the angular size of the objects. So I've got an angular size here of an aeroplane.
If we move up and down, have we changed the angle to the bottom of the wind turbine?
It wouldn't matter, Jeremy.
It's not
it wouldn't,
irrelevant.
Jeremy, please listen.
Irrelevant,
Jeremy, if you were to go up and down that photograph of the wind turbines, it wouldn't matter in terms of the angular size of the wind turbines, whether you were 100 feet higher or 100 feet lower. It would have the sea being in the way.
It would if the ground is one of the lines of that angle.
Look, I can show you. Here,
I have a question for you, Rumpus. What's the angular size of the wave there in front of your water, in front of your wind tower?
Get
What's
above
the
the
angular
surface.
size of your wave?
Irrelevant. So
Irrelevant,
here, for instance, is the angular size change of an object. I've got this lift going up and down.
I don't need an angular size change lesson, Rumpus.
You do need it.
I know
you don't understand that you've changed the angular size of your checkerboard things because you're looking at edge on. But we're all talking about things that are perpendicular, as Ruhif said. So your example is utterly irrelevant to the wind turbine example. And I'm trying to show you here in this diagram. I'm trying to show you in this diagram I've got on scene how the angular size changes as a result of it moving up and down. And it's not very much, even when it's quite close to you.
Okay, let me just walk you through this.
It's got to be miles and miles away for the bottom to play a factor.
And when you've got something like
that wind turbine is miles and miles away.
Exactly. So you moving up and down would not change the angular size of those wind turbines if you could see through the sea. So your example with the chessboard is utterly irrelevant. The things you're looking at are perpendicular to you. So just like I've got an example.
You can see through the sea. Just say if you lift it in the air. If the ground blocks shit, the ground blocks
but I'm talking about the whole. There's an effect due to you getting up because you can see above the sea, so you would see more of a wind turbine that's obscure. Okay, a wind turbine that was in front of you.
I thought things lean away from us on the equator.
Be quiet.
They're not perpendicular, right?
They're within a degree, so you don't need to worry about them. In fact, they're much less than a degree, the bending back. So, Jeremy, imagine one of those wind turbines. I think one of them was actually this side of the horizon. So imagine when you were looking at one of those, you could be moving up and down by 100 feet, and it would not change the angular size of the wind turbine.
But it would
Do you
change the
understand
angle. But it would change the angle to the bottom of it.
But we're worried about the angular size, Jeremy.
Does changing your angle change the angular size?
No, it doesn't. That's the point.
Then why does the last square disappear on the checkerboard?
Because it's parallel to your line of sight, not perpendicular.
Have you not listened to a word that Ruhif or I have been telling you?
Listen.
All right. Listen up, guys.
Jesus Christ, you're being really dim here, Jeremy.
We're going to wind down here. You guys can continue. Oh, why am I hearing myself? Got a full echo.
I don't hear any echo. I do hear a clock ticking.
Well, I don't know if the audience is hearing it, but we're going to wind up. We got a super chat from C4. Can we let Brian talk? Jeremy is boring AF. Shots fired.
Yeah, shut the fuck up, Jeremy. No, I'm just kidding. Listen, why are y'all not considering the ground as part of... Listen, when we say the ground blocks shit, we're talking about an angle drastic, like the angle when you put your face down to a checkerboard, to a chessboard, okay?
Jesus.
No, so if you put your face down... Let me finish this simple little point. If you put your face down to a checkerboard, then you're cutting off the angle drastically, right? But you can still barely see it, okay?
Irrelevant.
So it's not irrelevant because it takes a few miles.
Look at my wind turbine
photograph
I'm showing you here.
It takes a few miles to equal that angle, but that is the angle we start losing.
If you look at my
I've
photograph,
got a good analogy.
If you look at Walter or whatever,
look.
All right. Hey guys, we're gonna go. We're gonna go to final thoughts. Final thoughts. We're gonna go into final thoughts. You guys can keep talking about this afterwards, though. Why don't we start off with you, Brian Leakey? Thanks, Brian. Chad, what's up? You got any final thoughts? Perfect. Thank you, Chad. Ed. Hello. Sorry about that. Jeremy. We're having some audio issues. I guess there's no Discord. There are people talking. I don't know all of a sudden why it decided not to get the audio through. The audience can't hear you. Let me get out of here real quick, and then I'll be right back in like 2 seconds. All right, we'll try that. I'll try to go back into the channel. Hopefully that works. All right, George, final thoughts. George, final thoughts. I said I would be gone 2 fucking seconds, you guys. 2 seconds. George, go ahead. That's all right. Okay. Thanks, George. Yeah, we love our audience. Matrix.
Inches of still water with convection, something about duck poop, and maybe this would not be possible because of science. So
You don't
that's
want
what
me
I
to
learned.
sing.
Yeah.
Oh, sorry, Aaron. I forgot that you guys could hear me. Okay, I
Yeah.
think they hear you now. Okay, excuse me. Aaron, I apologize for interrupting you. Ruhif.
Yeah, to Jeremy, if you go up or down in elevation, yes, the angles to the top and the bottom of the turbines will change, and it is 100% irrelevant. In terms of the angular size, I have to say the wheel has turned full circle. It's now flat earthers denying perspective, and I'm sure we'll discuss this in the after show. Thank you.
Yeah, shit is on, motherfucker.
All right, I'll lock my door. 1 sec.
SC Montreal.
La La Land.
Bob Dole. No, he's on mute. Rumpus.
Right, okay, looking at my diagram here, let's just try this one last time. These wind turbines, if you imagine one is at the horizon, it doesn't matter what your vertical height is. The example that Jeremy was obsessed with this checkerboard was because he was then making things edge on. We're not discussing that. We're discussing the things disappearing from the bottom up, and we're talking about the vertical amount that's removed due to the curvature of the Earth. And we can see in this example here that the angular, well, this wind turbine, and we can see lots of them have got things hidden. I've drawn in them what is missing. And you cannot account for that for any discussion to do with Rayleigh criterion or whatever. We can clearly see the tops of the wind turbines, but we cannot see the bottom. And that can only be due to Earth curvature. The Rayleigh criterion is only relevant to when things become so small you can't see them. And Jeremy's got all confused about checkerboards when he should be thinking, oh, look, this wind turbine the tallest one that I'm going to claim is on the horizon. If you were to go up and down by 100 feet, it would not change its angular size.
As opposed to jumping in a
What the hell
helicopter.
are you doing, Rohit? His final thoughts. Go ahead, Rumpus. Finish up.
Oh, sorry.
That's all
I
right.
thought we're done. Sorry.
I'm nearly done. And so the only thing that can account for things that we can see clearly, we can clearly see the top of the wind turbine, but we can't see the bottom. So it's clearly resolvable. It's clearly big enough to be seen. So the Rayleigh criteria and all that crap is totally irrelevant. We need to account for it's missing. And the only thing that can account for that is it's being obscured. And it's being obscured by the curvature of the Earth. Finished. Go ahead.
All right, thanks. My final thoughts. Thanks for joining the panel, everyone.
Hold on, Brandon, if I could cut you off. I'm sorry. This is, phase one. I got cut off. I'd like to say a big shout out to the Plain Truth, who did roll through my town, and we hung out for the past day and a half. Had good eats, went to a couple jobs together, and generally just hung out. And he's a fucking good dude. So shout out to.
I'm jealous, man. That's bullshit. I'm jealous.
That's awesome, man.
True story.
You'll have to tell us what kind of trouble you guys got into. My final thoughts. Thanks to the panel for joining us tonight. Appreciate it. Sorry about the late start. Hopefully the internet provider has finished doing whatever the hell they've been doing in the area that's screwing us up. We'll be back on Monday. Until then, have a good weekend, and I'll be back. I'll record the after show. Sounds like you guys got some stuff to talk about. Give me a couple minutes. All right. Thanks, everybody. Appreciate it. And thank you for dealing with the tech issues that we've been having. I think I got most of them cleared up if this ISP doesn't keep doing maintenance during the show window. I'll have to call them and see what the hell they're doing, if this can be an ongoing thing. But anyway, we'll see you on Monday. You guys have a good weekend, and we'll talk to you then.